Cast is now starting. All attendees are in listen-only mode.
Yeah, hi. Good morning, good afternoon, good evening, everyone. Am I audible? If anybody can confirm that I'm audible. Okay, great. So I'll wait for another 5 minutes. We'll wait for another 5 minutes to join other participants as well, and then we'll start our session. Okay, great. I think we should start our sessions. Please let me know if I'm audible and my screen is visible to you. Okay, great, great. If you see any difficulties, please let me know so we can troubleshoot that one. Okay, I think most of the people already joined these things, so we'll start our sessions. So meanwhile, if anybody have any questions, any queries, you can directly ask in our Discord channel. You can directly put it your query based on our time slot. We will be discuss on those queries that you will ask. Okay, okay. So we'll start. Okay, so basically today the agenda of this whole training is to understand about different cloud attacks, how we can perform red team operation in different cloud providers, and where when they are connected to each other. Suppose the organizations, when the organizations using hybrid multi-cloud environment, where they have the traditional Active Directory environment, and along with that they have other services of these cloud providers like AWS, Azure, and GCP. From a threat actor point of view, from a red team point of view, from a pen testing point of view, how you can perform a red team operations on these cloud providers. Because this is completely different than the traditional red team assessment that we'll do in internal as well as external red team assessment. This is a new area where people don't have that much of expertise in this area, and a lot of new stuff is coming into market. So it is it's still there are a lot of places to be discovered in those areas. So our motive is to understand about how different cloud access management work, how we can perform different cloud based attack there, and how we can perform actually in a red team operation, not just compromise one service, one account. We have to compromise all organizations, whereas organizations are connected to multiple networks and multiple cloud providers. So that's our main objective. So today's sessions will be discussing about how the hybrid architectures look like, because from the red team point of view you should also understand that what will be your objective when you do what will be objective when you do red team assessment. Just like in a traditional Active Directory environment, our objective is to become a enterprise admin, domain admin, or steal some information, but in a cloud side it's completely different. So we have to also understand about the architectures, how it's look like when organizations are using federation identities or and workload in these multiple cloud providers. So in today's sessions we'll discuss about the architectures from red team point of view, from threat actor point of view, how it's look like. Then we'll also discuss about AWS cloud, how you perform red team operation on AWS cloud. So first half we'll discuss about the fundamental of AWS cloud, and second half we'll discuss about how actually from the just from starting from one point, how you'll actually perform a whole red team operation and compromise the full account in AWS. So that's the agenda for today. Tomorrow we'll discuss about the same operations. So first we'll understand the fundamental in Google Cloud, Google Workspace, how it's completely different than any other cloud providers like AWS and Azure. And second half we'll discuss about how you can actually perform a red team operation on Google Cloud. Last day, third day, we'll discuss about Azure cloud along with some on-premises, like how you can literally move from your on-premises to the cloud environment. So this is the whole agenda of 3 days training. Anybody have any questions in this way? Otherwise, we'll start our session. Any queries, any questions regarding the sessions? Yeah, yeah. So basically, how does it work? When we're talking about, so I'll tell you the scenario. In this particular trainings, we have a 3 days training sessions. that will be recorded. So if you miss something, you can go and you can recheck the recorded videos again. Apart from this thing, we will also share Terraform scripts is already uploaded in our LMS system, so you can download and you can run against your you can use your own AWS, Azure, and GCP accounts to perform different attacks based on the Terraform script that we designed. Walkthrough is already there in our LMS. Third one is we call it a demo lab, basically the lab that you are doing. So this 3 days training is completely hands-on training. So we'll do some red team assessment on one of the organizations here. I'll share some credentials with you. So that is part of demo lab. Demo lab is only accessible during the trainings. That means demo lab is only accessible during these 3 days. So where you can you can all do the same red team assessment there, understand how actually things are going on, and you can practice along with me. And that's necessary. Otherwise, you will miss a lot of things there. So I request you to please do it along with me, understand the concept, and then get some practical exposure. After that, we will share the 30 days full-fledged a big cyber range lab, where it's just like a simulation of an organization, where we have an Active Directory environment which is connected to AWS, Azure, and GCP. So it's just like a simulation of a whole organizations. So that's basically a challenge lab, or we can say practice lab, that will be available for 30 days. So you can practice. Your motive or your objective is to compromise AWS, Azure, GCP, and compromise whole organizations together. So that will be valid for 30 days. So this is just a practice lab. Once you are confident enough, you can enroll for an exam. So there will be 24 hours exam for the CHMITS course. 12 hours will be for your practical hands-on. You have to achieve some objective, and next 12 hours will be your reporting. So you have to just summarize how you did it, what you did it. Suppose if you are a red teamer, how you give these things to your audience, how you summarize it. So you just need to summarize it briefly and just share the report with us. So that is the pattern that we follow. So definitely there are two sort of lab. One is challenge lab, another one is demo lab. Demo lab is the lab that will be available during the training session only. So I'll share the credential. So we'll go for AWS first, then Azure, and then GCP. After that, we have a 30 days practice lab. So you can request for practice lab anytime. So once training is completed, you can request for any time. The day that you request, lab will start on the same day and will be valid for the next 30 days. We don't share any sort of references there, so you have to do a lot of research. You have to understand how you can do it. If you stuck somewhere, you can directly reach out to us on our Discord channel. And once you are confident enough, you can go for an exam. Any other questions here? Okay, I think we are good to go. Okay, so you can see here, the first we discuss about the fundamental of hybrid multi-cloud environment, because traditionally we have Active Directory environment. Traditionally we have some external network, some internal network, which is there in on premises as well. But now we organization are using, they have their workload in different cloud providers, and all are connected together. How it's possible? What we think from a red team point of view, from a threat actor point of view, how it's look like. So we'll discuss that one first, and then we'll start with the AWS cloud. Okay, so when we're talking about hybrid cloud, is basically combination of your on-premises, the traditional Active Directory environment, or any other external or internal networks, and we have a multi-cloud architectures, how AWS, Azure, and GCP architectures look like. Okay, so let's see. The first we'll discuss about just a brief about how the on-premises setup look like. So you can see when you're talking about on-premises, this is the typical network followed by different organizations. So you can see we have a internal network, which is our traditional Active Directory environment, where we can say it's an internal network, means which is employee can access the internal resources within the premises. Now there is firewall sitting between your internal network, and there is firewall sitting between your internal and external network. So external network means before cloud like organizations, they are deploying their applications, their DNS mail server in their own their premises. That means it's part of organization only, but this external network is directly exposed to the public audience, so they can use or they can access these services. Now this is a typical architectures look like. Okay, now when we're talking about Active Directory environment, why it's important? Because when you're talking about big MNCs, how the typical architecture look like? Suppose in this case, you can see there is one domain called abc.com. So suppose one organizations can have multiple domain, or that can also possible if one organizations acquire any other organizations, and they allow identity means employee to employee which is part of one organizations to access the resources in another organizations, or cross resourcing. This is happening because of that there is a trust relationship between both the domain controller. So this is the main primary domain, abc.com. There is one more domain, xyz.com. Now in between there is a trust relationship. It's so there will be one directional bi-directional trust relationship is there. This depend upon how you want to access the resources. Now you can see like in this particular domain there are multiple subdomains which is part of this domain, and there is identity means employee which is part of any of the subdomain or any of the domains there. Why it is important? Because we just see how cloud environment look like from a traditional Active Directory point of view, because they also follow the some sort of the same structures, but vary from the their different nomenclature, or different things are vary, but we'll discuss in detail. So this is a typical Active Directory environment look like. Okay, now when we're talking about multi-cloud architectures, let's first discuss about AWS. How AWS look like? So you can see when we're talking about a single account, like you can go and you can purchase for AWS account, right? Now you can see AWS is divided among the regions. So you have a resources based on region. Like some resources you have in US region, some resources you have in Asia Pacific, some resources you have in Europe region. So resources are divided or allocated among the regions, but all the regions are part of single AWS account. Now, that's the one thing. It can be part of an organization or cannot be a part of an organization. What do you mean by? The means is, suppose when you're talking about organizations can have a multiple AWS account, hundreds of AWS account. How we can manage those AWS account, and how the accounts are connected to each other. So you can see this is the architecture of single AWS account. Now from a RedTeam point of view, your motive is to compromise this whole AWS account here. That means you have access on all the resources which is part of any region, right? Now when we're talking about organizations, they have hundreds of AWS account. How they are connected to each other? So when you're talking about organization, you can see there are multiple AWS accounts that we called as a child accounts, or we can also call it a member accounts. So these are the members account, AWS account, which are connected to a single master account. Now you can see master account is similar like any AWS account, but these child accounts are connected to this master account, and master account is responsible for managing these child account. So these child account is similar like your AWS account. You just configure to, or you just map to your master account. So in this case, what happened? If you compromise this child account, what will be your objective? Your objective becomes to literally move from this master account, this child account, or this member account to this master account. Because if you compromise the master account, you have access on all the child account or all the sub accounts which is part of master account. So that is really important from a red team point of view. If your objective is to not just compromise a single account, your objective is to compromise this master account. So we'll discuss, there are different ways are there that will allow you to laterally movement from child account to the master account, as well master account to the child account. Suppose in the first phase you compromise the master account itself. Now if you have access on master account, how you can laterally move from master account to the child account? So there are multiple ways are there. Okay, any questions here? So this will be the typical architecture which organizations follow. And in our lab also, we will follow the same sort of architectures. Now let's move to the cross account access. What do you mean by, like in this case, suppose if you have a access on this particular account, how do you get access on this child account? How do you get access on another member account? This is possible in AWS because of the cross account access. Just like in Active Directory environment, we have a trust relationship, right? Similar like in AWS, we call this a cross account access, or we call this a assume role. Assume role will allow us to provide a cross account access. Suppose you can see there is one identity which is part of this development account. Now, with help of assume role, that means we build a trust relationship between these two accounts. So identity from one account can access the resources in another account. This will help us to literally move from one account to another account. That can be possible from your one child account to another child account, or your child account to the master account, based on how trust relationship are designed, or how or what sort of access do you have. Okay, so this is a typical architecture. Single account, how it's look like. When you're talking about multiple accounts are clubbed together, this is and when we're talking about cross account access, this is possible. We'll discuss in detail when we do a RedTeam assessment here. Okay, any questions here? No. Okay, now let's move to the Azure things. How Azure will look like. So AWS, you can see we have accounts. You can create multiple accounts, and you can manage all these multiple accounts to from your master account. Now we're talking about Azure. There are three different components are there. Just like with Azure Active Directory environment, which is slightly different than your traditional Active Directory environment. When we discuss in Azure, we'll discuss in detail. Now we have another thing called Azure Resource Manager. So suppose if you want to create any virtual machines or any sort of resources as part of ARM, or if you are going for any sort of mail services or any other services, that is part of your Office 365, or you can say M365. Why it's important? Because these three different components are is used for different purpose, right? So from red team point of view, what is your objective? If your objective is to uh, basically compromise or steal the information which is there in database server or storage, then you have to compromise ARM. If your motive is to compromise or access mail, drive, or any other information, you have to compromise Office 365, or we can say M365. Azure AD is mainly used for authentication for both, either if you use ARM or any sort of Office 365. Now this is the architecture of single account, or in Azure we call it as tenant. This is a single tenant architecture. So you have a tenant. Inside the tenant, you have a multiple management group. Management group, you have a subscriptions. So similar like in our AWS account, we have a multiple accounts. In Azure, we have a multiple subscriptions. Inside the subscription, we have multiple resources there. Resources can be your virtual machines, storage, or any other sort of resources. And we have a resource group, which is basically a containerized to all the resources, which is part of this subscription. Okay, so we discuss about AWS Azure. Now we are going to discuss about GCP, how Google Cloud look like. So Google Cloud have a similarity like Azure. AWS is completely different than Azure and GCP, but both Azure and GCP have some sort of similarity. Similarity in terms of components. Similar like in Azure, in GCP we have these three components: your cloud identity, your Google Cloud platform, and third one is your Google Workspace. Suppose if you want to create any resources like virtual machines, RDS, or any sort of resources which will be part of your Google Cloud. Now, if you are using, suppose, mail services, uh, or if you are using documents, Google Meet, and all these things, all are part of Google Workspace. And cloud identity is mainly used for authentications. So this is a similar like an Azure we have. We have Azure AD. So instead of cloud identity in Azure, we have Azure AD. Google Cloud Platform, we have a ARM, Azure Resource Manager. And third one is instead of Google Workspace, we have Office 365. So this is a just like a naming difference. All these things we'll discuss in detail when we discuss in these particular cloud providers. But this is a give you a idea about how all these three cloud providers look like and how it's look like from the red team point of view. Now, if you're talking about Google Cloud projects, Google Cloud platform. So the GCP where you actually creating a resource, this is hierarchy look like. You have a multiple departments. Departments means it's just like a folder. It's like optional thing. And we have a project. So AWS, we have a AWS account. In Azure, we have a subscription. In GCP, we have a projects. So project is a security boundary. Basically, you can create a multiple project, similar like you can create a multiple AWS account. Now, project is the main where we have actually the resource, where we are creating a resource like your compute, app engine, storage, or any other sort of resources that you are going to create it. But that will be part of this project only. Okay, so any questions here? Like related to AWS, Azure, and GCP, how it's look like? All these things we'll discuss in detail, but as of now, anybody have any questions? I'm just sharing one credentials with you in our Discord channel. Just give me 1 minute. I'm just sharing one credential, so you will get a better idea. So suppose this is a credential that I'm sharing is part of. So this is a credential which belongs to employee of an organization. Organization's name is atomicnuclear.site, and the password also I'm sharing here. Okay, so we'll discuss. So this is the credentials. How you can authenticate basically these credentials. So suppose in your organizations, I'll just show you how it's work. Let me just show you some demo, and then we'll see how it's look like. So basically how it's look like, suppose if you have organizations, this is the organizations. Organizations means organization using their Active Directory environment in their on premises. So this is there in on premises. Okay, now employee is part of this Active Directory environment. They have username and password. Okay, now what happened this, so you can go and you can log in any of the resources which is part of this organization, that means which is there in their Active Directory environment. Similar like you can access their VPN services, you can access, so you need the same credentials, the same username and password to access this is a traditional method, right? Now think about a scenario. If you have AWS, you have Azure. So these informations are there in on premises. That means it's not exposed is there in their internal network. All this information are there in internal network. Right? This is the internal network where all the information are there. Now what happened? Suppose in this case, this is your Active Directory environment. You have your employee, which you have a username and password. So you can authenticate within your internal network. Most of the organizations, how they expose, or you can use the same credentials to access multiple cloud providers like AWS, Azure, GCP, or any other SaaS-based services. This is happened because of your external identity. There is a called external identity. External identity. It can be your Okta, it can be your one login, or it can be your ADFS, Federation Services. It can be anything like these are the external identity. Now what happened in this case, all the credentials or their informations will be syncs to your external identity. All there is no like not all the cases credential will be sync, but informations will be synced in to your external, depend upon how you configure your or how your external identity configure it. So you can sync the informations like your employee and all the users information, group information syncs to your external IDP, and these external IDP are connected to your AWS, your Azure, and your GCP. So this is not just limited to AWS, Azure, and GCP. Any other, suppose you can also have your HR Berry or any other like your any other services you can also use, or any other SaaS-based solutions you can also configure with your IDP. Now, what happened in this case? Think about a scenario. So if you log into Azure, like suppose a user want to access or want to log into AWS, what happened? This AWS will redirect to your external IDP, and your based on your external IDP, you will be again redirected to your AWS. This is how it's configured, because in the backend there already trust has been built here and here. Here the trust is built because of the sync happen from your AD to your external IDP, and here the trust is built because of either you have options called SAML or you have a OIDC. So there are two ways you can build the trust. That means, suppose if you want to access AWS, it will redirect to your external IDP where you authenticate, and then you can access your AWS portal. The same structures that we configured in our lab. So suppose if you want to go here, and let me open this one second. Okay. So now very simple. Suppose if you want to access AWS. So when we're talking about AWS, there are two portals that is exposed to the audience. One is this one. Like you can log in, but in this case, you have to be logged in where you have to specify your username and password. These username and this password should be belongs to AWS. But in our case, this username and password is not belongs to AWS. That belongs to our external IDP or our Active Directory environment. In that case, organizations have their SSO URL. So each and every organizations, they have their own SSO URL. So suppose if you want to log into AWS, you'll go. This is SSO URL for my organizations. It will be Atomic Nuclear and then AWS apps.com. Suppose your organization name is ABC, their SSO URL will definitely be abc.awsapps.com. And then you can use start. Now, how the things happen? Let me see. So you can see it will, you can see what happens. See, if I use again, let me see it clearly. It will first go to AWS, and in the backend, one second, if you use start, this is the main URL of any federation things. You can see in the backend, it will be redirected to me to the Azure. Why this is happen? In our case, so in external IDP, you can use Okta, OneLogin, ADFS, or you can also use Azure as a external IDP. External IDP. So every time if you log into any of the application, you will be redirected to the Azure, and where you authenticate and then you can log in again. So this is the fundamental, and you can configure through SAML and OIDC, Open ID Connect. So now you can see it here. You can specify the credentials that here, and yes, you can see all the accounts that belongs to me. You are able to see it here. Like you remember we discussed about the architectures, AWS architecture, how they look like. Suppose if AWS have a multiple AWS accounts, how it's look like. If you have a single account, you can directly log into console.aws.com. Uh, but if you want to log in to your SSO or federation credentials, you have to log in like this. Okay. Now we understand that in our case, what we are going to do, we are going to have a Azure as a external IDP. Okay, now how, suppose if you want to log into the Okta, you just specify your company name .okta.com, right? Now in this case, if we are using Azure services as an external IDP, this will be our URL. Our URL like this, myapps.microsoft.com. And you can see I'm authenticated as employee 01 user. All the applications are belongs to me. You can see it here directly. Similar like when you log in Okta, when you log in one login or any other external identity provider, you can see all the applications that belongs to you. You can simply see the applications here. Okay, it's not just bound to AWS, Azure, and GCP. Any other SaaS-based application you can integrate here. Okay, so from here also you can directly access. So when you click here, well, I'm just sharing this one in Discord, so you can also try it to understand how, because why it's important. You can see it will redirect to me to Azure again, and then it asks me to authenticate. Yeah, you can see all the accounts that belongs to you, and you can authenticate it here. You can also access Google Cloud directly. So in the backend, because we already have, so you can see I authenticated to the Google Cloud. Just my so you can change it, I think, because I am logged into multiple accounts. That's why. Otherwise, you can directly access. You can see I authenticated with this user. So same credentials I use to access multiple services here. Why? How this has happened? Because of the federations in between, and that's called hybrid multi-cloud environment. This has happened because of your identity are federated amongst multiple cloud providers there. So if you compromise a single credentials or employee credentials, you can access multiple services that belongs to this user. So, and based on the access defined there, you can also see. So you can see it here in Azure. You can see multiple things are together. Okay, so you can see you can even access graph. You can we'll discuss what is graph API, how it's look like, but you can see multiple things here. Okay, any questions here? Try to authenticate it. Why it's important? Because otherwise we'll skip the actual architecture of how internally they are connected to each other. That is comes into everybody's minds when you're talking about hybrid cloud or hybrid hybrid architecture. How it's look like hybrid multi-cloud architecture. So this is the architecture look like, and this is possible because of the federations. In this case, we have a federation of identity here. Okay, now let's move to the next one. There is one more connectivity that's happened among the cloud providers is based on network connectivity. Like in this particular case, we have a federation connectivity, identity federations. That means using single credentials, we can access multiple cloud providers. What about if you want to access, suppose you have a virtual machines which is there in, suppose let me clear it and you will get an idea. So let me just, okay. Now, so there are three sort of federations there. In PPT, we only mentioned two type of, but recently in our research we found there are three sort of federations are there, or three sort of connectivity is there. One is very simple. Suppose one is the connectivities happen because of your network. It's really important. Connectivities happen because of the network. What do you mean by network? Suppose, let's say if you have, let's very simple, you have Active Directory environment, or don't say Active Directory, just say simply on premises. That's external, internal, everything is part of this one. And you have a cloud providers, AWS, let's say Azure, and let's say Google Cloud. Okay, now suppose if you have a VM which is running here in AWS, and suppose there is one VM which is running there in AWS, and there is one VM which is running in uh, Azure, or there is one VM which is running in this one. How they can access it to each other? That is happen because of the network connectivity among these cloud providers. So you have a network connectivity. Network connectivity means you can access resources of, or you can directly access the VM which is part of Azure from your AWS. There are two ways. One is cloud providers, they have a called site to site VPN. This will allow you to create a VPN tunnel from one site like AWS, one network of AWS to one network of Azure, or that means from you can access from this point of view, or you can access from this point of view. That is very common scenario, and very cost effective as well from organizations. So you can have a site to site VPN from AWS to Azure, Azure to GCP, anywhere. So you can have connectivity from anything to anywhere. That's called site to site VPN connectivity. There are one more techniques that's called a lease line. So they provide a basically the different services, like you have a data store in your on premises, and if you want to connect to that data store to your AWS, in AWS we have a called direct connect, in Azure we have other services, in GCP we have other services, but that is very costly as well. So most of the, when you do red team assessment, when it's a medium sized organizations, when it's a large organizations, they use lease line or they use these direct connect options. But when it's medium or small size of organizations and they want to access the resources, they typically use site to site VPN. Why it's important? Because sometimes in red team assessment you compromise one cloud provider and you want to access the resources which is there in another cloud provider. You are not going to access the other cloud provider, you are going to access the resources which is there in another cloud provider. This is happened because of the site to site VPN connectivity. So you will see how the connectivities happen from your AWS to Azure and any other cloud providers. So this is one connectivity that's become as a hybrid multi-cloud environment. This has become a hybrid multi-cloud environment, this complete architecture, and this is possible because of network connectivity. So you have multiple options. Mainly these two options are used by organization. One is site to site VPN, which is cost effective, and you can use it. Second one is called a direct connect, or we can say lease line, which provide a direct connectivity to your data center basically. But that's it's costly than site to site VPN, and mostly large organizations are using this, this particular things. Second point we have called, this has happened because of network. You can access the resources, like you can ping it, or you can access one resources from one provider to another provider. Second, it's happened because of the identity federations. So it's called identity federations. Similar like we saw just now we saw. So if you have your identity here, like your employee or any credentials like employee one, using the same password username, you can access multiple cloud providers or multiple services. You can directly authenticate to these cloud providers. That's happened because of the identity federations. And from a RedTeam point of view, it's important. Suppose if you compromise one user account, you can access all the accounts or all the cloud providers that belongs to this AWS, this particular employee, or employee have access on this one. And this has happened because of the, either there is a two sort of, this has happened because of the federation. Federation can be possible with SAML, or it can be possible with OIDC. Okay, so there are two ways you can have a identity federations there. Recently, most of the organizations now these days are using called workload federations. Identity federation, simply the identity federation is belongs to a user. So user can use same credentials to authenticate. But now these days, suppose in this case, you can see this is your AWS account. And there is one more. This is any other cloud provider. Any other cloud provider. Now you can see there is a one application running on VM of your, suppose let's say it's a Google cloud provider. If your application running here, so you are using VM here in GCP, but you are using RDS here on AWS or any other, like you can also use S3 bucket. So just for example, how we can provide access. So suppose your VM want to access, suppose VM want to access some sort of data, or VM want to upload some sort of data, or any sort of upload download is happening on S3 bucket. How the federations happen in this case? Because in this case, you are not a user. So VM is not a user. VM is just like a workload here. So application running on VM can access resources of any other cloud provider. This has happened because of workload federations. In first case, you saw identity federations. That's happened because of SAML and OIDC. Same kind of things, we can have a workload federations, which is generally happen in OIDC using OpenID Connect. But in this case, won't be any human interventions. That means there won't be any user credentials. All we have is application credentials. So we'll discuss how the application credentials as they are in AWS, how is there in Azure and GCPs. But these are the three sort of federations we have in when it's become hybrid multi-cloud environment. And these are the scenarios generally organizations are following. Okay, any questions here? Anybody have any questions here? Because these are the important things. Otherwise, you won't. Suppose when we directly go in RedTeam assessment, when organizations are using these multiple cloud providers, this is not just AWS, Azure, and GCP. You can also use IBM, Oracle, Alibaba, or any other cloud providers. They also follow the same. So if you want to connect these cloud providers, this is the same options we have. Yeah. Okay, so let's see. You can see it here. From identity point of view, you can directly see it here. If you want to access, so you have one credentials, employee 01, no other credentials you have. This has happened because of the identity federations happen. So if you log into Azure, by default you can access it, because Azure we are using, it's not going anywhere else, because Azure is the our external identity provider here. So you can access it. Like you can see, you can access it. If you want to access AWS or any other cloud services, in the backend we have a open ID Connect federations happen there, and this is happened because of the federations between identity. Yeah. Any questions? Yes, please. Anybody have any question? Okay. Any questions? Most of the no. Let me clarify this one. Just a second. Just a second. I think it's better if you can ask the question directly on Discord instead of go to, because it's easy for me. Okay, so you are asking the questions so basically most of the multi-cloud architecture will connect from on-premise to the Azure AD and then other rights. No. So how does this happen? Again, I'm just repeating here. Very simple example. It's very simple. I'll just give you one brief. So think about a scenario. Again, I'm repeating here. Think about a very simple scenario. If you suppose organizations, they have by default, most of the organization, I'm not talking about all, but if organizations, they have their on-premises, this is their on-premises, means their internal network. And suppose the organizations using Active Directory environment, and you have multiple users, multiple groups, and all these things right here. So you have suppose EMP01. This is a normal case. Now you have multiple cloud providers, AWS, Azure, and GCP. Okay, now you understand that if you're using the same credentials, or if you want to have the identity federations, means the same credentials can use to authenticate to the multiple cloud providers. So if it's not possible, generally you have to create an account in AWS and you have to share the credentials. You have to create another account in Azure and then you have to share the credentials. You have to do same thing with any other SaaS applications. But this is this can be reduced by identity federations. Now most of the organizations, how they have their external IDP. It's called IDP, external IDP. Why I'm talking about external? Because the main IDP is the Active Directory environment. This is the main IDP where we have identities, but this is called external IDP. Why we have external IDP? Because of this Active Directory environment are they're in internal network. It's not exposed to the any public this one. In that case, if you are a part of internal network, you can only authenticate. Because suppose if you are there in any other location or outside of their on-premise network, how you can authenticate? In that case, you can use external IDP provider. So the first things that organizations can have, it's called ADFS, Active Directory Federation Service. That means they have one federation server which is exposed directly to the cloud or public, and they have the connected between these things. Second thing, they can go for a one log Okta, which is very popular identity federations. Then, oh sorry, provider. Then we have a one login, and Azure is one of them. Azure AD also provide a identity federation service. It's just like one of them. If they are not using Azure AD, they can use any other federation services. Suppose they can use Okta. And in the backend, so you can see all the synchronizations is happening here in this case from your on-premise to the external IDP. That can be Okta, ADFS, one login, or any other things. Now, how we can build the trust relationship? This is so you have to build the trust relationship from your external IDP to all the cloud providers that you have. And that is possible because of either SAML or your OIDC. So there are, as of now, I think there are only two methods that will allow you to federate the identity. This is a possibility because federation of identity. Now, in our case, what we are using is, so we are using Azure AD as a external IDP. Now, if you log into any of the cloud providers, suppose if you log in AWS, like suppose if you log in here in AWS, it will redirect to you Azure, sorry here, and then again you can authenticate here. If you log into the GCP, the same thing is happen. It will redirect to your Azure AD, sorry, Azure AD, and then okay. So if you log in here, it will redirect to your Azure AD. Let's see. And if you log into Azure, it will be in the background. It won't redirect anywhere else. But in the you can see it's happened in the same case. So in the backend, in the background, it will be connected to your Azure AD. So that's why this is the possible. So instead of Azure AD, you can have any other sort of federations here. So it's not specific to Azure AD. Organizations can be use any other external identity provider. In our case, very simple, we are using Azure AD as a external identity provider. That means if you log in here, you can see all applications that assign to you, and from here directly you can access the application. Suppose you close everything, and if you want to access AWS, you can go and you can directly authenticate here. No need to provide the credentials, it automatically take the credentials, because in the backend we already, so you just need to authenticate here. In the backend, it's already, the trust is already built here. Okay, like this. Or if you want, if you can see, if I'm logging console.google.com, suppose if you want to authenticate with employee one credentials, no, I already authenticate, that way it's not redirect again and again. But suppose in this case, if I'm using employee 01 credentials, if you just specify, it will check this particular domain where this federation is happen, and then you can see it will go to your Azure page where you can specify your credentials, and then no, it won't. So yeah, so every time it not go to your Active Directory, because in the synchronizations, suppose if if you are using ADFS, in that case there is a possibility in ADFS case, there is a one connection happen from your ADFS to your Active Directory environment. But if you are using Azure AD, we already sync our all credentials to Azure AD. We already sync username and password to Azure AD based on how you configure this thing, but it's already synced to your Azure AD. So Azure AD is not every time connected to your your internal AD environment to see this thing, but there is a one-way connections happen. So suppose if you add any other user, suppose if you add or if you delete this user, this will sync is happen to your Azure AD. That means in this case here, and based on the changes you made will be reflected there in Azure AD. So you can see I authenticated here. Okay, so this is how the federations, and it's really important. These three kind of federation that we discuss is really important, because now these days all about federations, network connectivity, site-to-site VPN, and workload identity federations. No need to hard code the credentials. Everything just need to connect and how to apply the federation. It will work. So this is also important from a red team point of view, because if you compromise just one credentials, you can access resources that provided to your user or the user that you compromise it. Yeah. Okay, so one good thing I think that will give us some sort of idea. If you want to see what sort of federation or organization is using, I'll just sharing one URL with you. Now if you want to see for any organizations how the federations they are using it, this is the URL. You can see the federations, how the federation is happening. Let's say I'm talking about for my organizations, EMP01 is the employee ID, email address, and now you can see, if you go in detail, you can see what is the external identity provider here I'm using. So you can see I'm using, if you can see that manage, that means Azure it is responsible for your identity federations for this particular account. Suppose if we change it to any other domain, I'm not specify anything. Let's say if you go for a google.com, you can see they also use this manage of Azure AD. If you want to see, that means Azure AD is the primary, secondary identity, but it's managed. It won't redirect anywhere else. Let's say I'm talking about Uber in this case, uber.com. This is just for informational purpose. You can use any other domain. So you can see in this case, this is the federation URL that Uber is. So Uber is using one login. Every time if you authenticate to any other services, it will redirect to one login.com. And where you have to enter your credentials in the backend, you will be authenticated. So not all the cases, all the company are using Azure AD. Company can use any other, external identity provider, but Okta and Login are most common one. Company can also use basically your we can see ADFS as well. So suppose if you're using any .com, in this case you can see this is a federation. This is the federation URL, or you can use any other company. I'm not specific to any companies here. This will give you the idea how the identity federation happen, which identity provider, external identity provider they are using it. In the backend, definitely they are using AD or any other sort of things, but externally, which is exposed, where actually authentication is happen. Okay, so this, I'm just sharing this link with you, so you will get this will give you a lot of clarity. So suppose if you're doing red team assessment and you don't have much idea about organizations, this will give you a lot of clarity about it. One second. There is no such organization that was specified like this. If I change it to, yeah, I'm just sharing in your Discord. Okay. Any questions here in this case? Anybody have any questions? Keep in mind that when you doing practice in our big cyber range lab, you will see these kind of scenarios there. So it's better, like it will really help if you understand how the things is actually happening in the back end, because this is not exposed directly to the audience, right? But you should also understand the architectures, how the architectures they are designed here. Yeah, correct. Because in our case, you see what happened when you're talking about our organization's atomic nuclear, authentication is happening within Azure AD only. In that case, authentication is happening on Azure AD only. That's why there is no auth URL. If you are using any external IDP, that means all the authentication is managed by Azure AD only. That's why you won't see any sort of auth URL. So if organizations, if they are using Azure AD as a external identity, there won't be, and you can see there will be manage option will be there, but there won't be any auth URL. But if they are not using Azure AD as an external IDP, in that case, they the auth URL will be specified here. Okay, any question here? Yeah, definitely, definitely. I think there is a few point. Let's take an example of. I'll just summarize what has happened. So once just complete this one, and then I'll summarize what is happening there. Okay, so you can see the federations. If you have a network connectivity, you can have directly federations. And network connectivities happen. We can use the service like site-to-site VPNs to have a network connectivity among these cloud providers as well as on premises. Second thing is, in this case, you can see we have a one credentials which is there in Active Directory credentials, and you can access the same credentials to access multiple services because of the federations. Now, this is a complete hybrid multi-cloud environment. Suppose if you are a user, from AWS point of view, your motive is to compromise your master account. We call this a primary account, master account, or management account. This is account which is used to manage all other child accounts. So if you compromise this account, you can have access on all the other accounts. Similar kind of things is there in Azure. So you have to compromise or you have to access on tenant level. So if you have access on tenant level, you can access all the subscriptions there. Subscription is similar like our AWS account, which is mainly used for creating a resource or billing purpose as well. Now we're talking about GCP. You have multiple GCP projects there. So you have to compromise GCP organizations to have access on all the projects. All the projects are belongs to GCP organizations. So you have to compromise these organizations. In this case, you have to compromise this, this tenant, and here you have to compromise this account. If you compromise these three things, that means you compromise whole organizations. Okay, at the end, when we're talking about credentials, how these credentials look like. So in a typical Active Directory environment, what sort of credentials we have? We have we have our username and password. We have our NTLM hash. We have a net NTLM hash, like which is for a short period of time will be valid. Similar kind of things in Azure is in multi-cloud. Suppose if you are using multi-cloud services, how this credentials look like. So there are two sort of credentials. One is long-term credentials, another one is short-term credentials. Okay, now if you're talking about long-term credentials, there are username and password, and there is a your service account credentials. Similar kind of thing for a short-term credential, which is valid for only for short duration of time. It's called access token. So it's similar like in AWS, Azure, and GCP, but the their timeline or the expirations date are now all these things will be different here. But to be honest, there are two sort of credentials. One is long-term and one is the short-term credentials. So if you compromise, why it's important, if you compromise your short-term credentials, that because if you compromise short-term credentials, definitely that will be expired after a certain period of time. Just like GCP, we have for 33,600 seconds, that means for 1 hour. Similar like in Azure and AWS, we have a expiration time for these credentials. So if you compromise short-term credentials, your motive is to become or to escalate to a long-term credential. So you have a longer access of cloud providers. Okay, so this is a hybrid multi-cloud architecture look like. Let me summarize it in our case. What is happening here? Just a brief, and then we'll go for it 10-minute breaks. So I'm just summarize it here very quickly. Suppose in my case, what happened in our case, this is our Active Directory environment. Very simple. This is our Active Directory environment where you have a one credential called employee01. Now, what we have AWS, we have Azure, and we have a GCP. Now, one option is you can create an account in all three different cloud providers, and you can use multiple credentials here. That is one possibility. But if you have hundreds of account and you have other things, it's very difficult to manage. That's why organizations are using called federation identity, federated identity. What this federation identity does, this will allow you to use the single credentials to access multiple applications. When I'm talking of application means you can access multiple cloud providers. Yeah. Now, in our case, what we did, we first synchronize all our user and passwords to Azure, because I'm using Azure AD services here that will provide a federation identity service. Instead of Azure, you can have any other services like Okta, OneLogin, your external, like you can also use any external IDP as well. If you want, you can also do it. But in our case, we are using Azure only. So we sync all our credentials here, like our username and password is synced to Azure, and this is one way. So let's remove. This is one way. One way means everything will be synced from your AD to your Azure. Now your credentials will be synced to your. So this will be synced to your Azure. Any questions? Very simple. We sync all our credentials here. Now suppose if you authenticate to AWS. So suppose if a user want to authenticate in AWS, in backend what we did, we created a trust relationship. Trust relationship between here. This is a trust relationship. It's either you can use SAML or you can use OIDC. Same here, we did it here. We created a trust relationship with SAML or OIDC. Now in this case, on-premises role will just removed here because we already sync the credentials. So username and password is already there with Azure AD. Okay, now if you authenticate to AWS, what happened? Because when you AWS check your domain name, they say they found that it have the federations to Azure here. They see there is a federations happening to Azure AD. So they will redirect to your Azure. You authenticate here because Azure AD already have your credentials. And again, it will, once you authenticate, it will redirect to your AWS. Same thing happen on GCP case. If you log in here, because there is already trust relationship, so it will redirect to your Azure, you authenticate there, and again you will be log into your GCP. If you're login to Azure AD, it will authenticate in within the Azure AD itself. So this is the architecture we follow. Now, one question asked: a password write back was turned on while doing sync. So initially there was this option was not there. That's called password write back. Password write back means if you have a bidirectional sync. Like if you change the password here, it will be sync here. That was not there. So in our case, we have only one-way sync. One-way sync means if you change something here, it will be syncs to your Azure AD. But if you sync in Azure AD, it won't be reflected back to your Active Directory. But recently, like Azure AD connector have this functionality called passwords write back that will allow you to have a bi-directional sync. So if you made changes, suppose if you want to change the username and password of employee, you have to go there on premises, you have to change the password, and it will be reflected to your AD. That is a traditional case. This is one-way sync. But if you have a write back options, if you change it in Azure AD, it will be right back to your on-premises. So that's based on how the synchronizations you configured here in your Active Directory environment. So this is a case you can see it when you check for in this case, because in this case when you're looking for this particular domain and we are asking to Azure, you can see these URL is belongs to Azure Microsoft only, and if you want to check if this particular domain is managed by Azure or not, they say yes, it's managed by Azure only. If it's not, you will also found auth URL, just like uh, just like we see uber.com. If it's not managed, you will see you have to authenticate here in this particular URL. So this is typically, suppose if you log in portal.azure.com and if you specify any domain like employee01.uber.com, it will check in the backend where is the auth URL, well is managed by Azure or not. If you say it's not managed by Azure, they will see the auth URL and they will redirect you to the one login where you authenticate and you will log in back to your Azure portal. So this has happened in the backend. Okay, any questions here? I think when we do these things, you will get a more clarity. But if you have any questions, because these are the important things you should understand. And then we'll start with AWS and some sort of attacks there. Now we'll do red team operation in AWS side. So if anybody have any questions, but please make sure you are clear on this point. Okay, I think. Okay, any questions? Let me see. So we'll go for a 10 minutes break and then we'll start our AWS one. This just fundamental and then attack. So this will be complete hands-on. But this is important. If you have any query, any questions on this point, please let me know. Just a or if you're facing any difficulties, so I request you to please join Discord channel if you haven't joined yet, because you will get everything there in Discord. Okay, so we'll go for a 10 minutes, just a short break, and then we'll back and we'll be discuss about, we'll start for AWS and then we'll go for some sort of attacks there. Okay, just give me 1 minute. I'm just Okay. Okay. So, any questions anybody have in our last session? Like any confusion on federation identity, how hybrid multi-cloud architectures look like, what sort of connectivity, how do we have a connectivity? Any questions on that? Okay, if not, let's start with our second module. So in this module, we divided into two different part. One part will discuss about some of the fundamental of AWS, and a second part will discuss about how you can perform a red team operations on AWS account. Okay, so I think let's start with this one. Meanwhile, anybody have any question, just let me know. So first we discuss about how this fundamental is AWS 1.1, how the architectures, authentication side, and what are the different services of AWS have. After that, we'll discuss about identity and access management, because this is a core service of, this is backbone of AWS cloud, right? From using AWS, using identity and access management, we provide different sort of permissions, policies, and all these things, and that's happened because of the identity and access management. And then we'll discuss about some of the how we can identify what permission is assigned to users, to groups, to a service principal. So this is basically fundamentals. Okay, so now AWS have a multiple reasons that we all know, right? You have a US regions. In the US regions, we have multiple availability zone. Same like we have a different region in Asia Pacific, Europe, and all these things. Now, when we're talking about AWS architectures or any cloud providers, this is the architectures they follow. So you can see there are two different space are there. One is cloud space, and second one is end user space. So cloud space, there are three different components are here. The one is called GUI portal, where you actually log in there. So what happen if you want to create a VM? It will connect back to in the backend called control plane. Control plane is mainly used for your authorizations to check and what sort of authorized you are and what actions you want to take it. So it basically first check your authorizations. Are you authorized to do these actions? If you are allowed to do it, it will actions will be trigger on data point. So it will create your resources on data point. Okay, so you can see it here. So these are the three different component. You have a GUI, you have a control plane, and you have a data plane. GUI we can use just like recently we use it console or we can use Azure sorry AWS portal. You enter your credentials. Credentials can be a username and password or your federated credentials. So you in this particular case you require a browsers to authenticate to your portal. You can directly connect or directly authenticate to your control plane. That can be possible with SDK or API or AWS CLI. So you can connect directly to the control plane and you can perform the actions. So suppose if you want to create a virtual machines, you can directly go to GUI and you can uh, start the option or select the options to create a virtual machines here. In the backend, it will connect to the control plane. Control plane will check are you authorized or not to do these actions. If you are, they will do these actions and your actual resource will be created on data plane. So this is how this one. So control plane is just like fundamentals. It basically check the authorizations of actions that is executed or that is requested by the users or service account, and on based of the actions, it will take some sort of actions at the back end. So that means it will create some sort of resource in data plane. So this is same similarity like AWS, Azure, and GCP or any other cloud providers. They also follow like this. But in our case, what I'm interested in here is how you can authenticate here. So you can see you can authenticate using your username and password and your SSO. So you can use your web client to authenticate. That means you can access GUI. You can directly authenticate to a control plane with your access key ID, and you can use the short-term key or you can use the long-term keys here. Long-term key means the access key ID and secret that will be valid for a long duration of time. Short-term means it will be expire after a certain period of time. So yes, like how the credentials look like. There are two sort of credentials. One is your long-term credentials, and one is your short-term credentials. We'll discuss in detail in this point of view. Okay, now the important point: how you can authenticate basically to your. So let's see how you can authenticate. So suppose if you want to authenticate to the portal, this is a portal URL look like. So you can authenticate to the portal. Now you can see you can go here. Even in the portal, there are two different ways. One way is you can authenticate as a root user account, and second one is you can authenticate as a normal user account, right? So here you are authenticating as a root user account, so you just specify the URL of root user. If you are going to authenticate as a IAM user, normal user, you can authenticate. You have to specify the account ID. Account ID means the uniquely identify ID that belongs to your account. This is the case if you are authenticating to AWS console or AWS portal. Third one is if you are using federation credentials like username and password, but that is federated. You can go for this particular URL, your organization's name, and then awsapps.com, and you can authenticate here. Very simple. Second point, if you are you can use AWS CLI to authenticate this one as well. So in this case, you can see I'm using AWS CLI to authenticate. So in that case, you required your access key ID, you required your secret to authenticate. Once you authenticate, you will see like this. Okay. You can also use, this is the long-term credentials, and long-term credential access key ID start with AKIA. But when you're talking about short-term credentials, this is short-term credentials. You require access key ID, you require secret, and you require token as well. That token will be expired after a certain period of time. So you can see you can authenticate with the short-term credentials with your AWS CLI like this. And when you're looking for the key ID of AWS, you can see it start with ASIA. But when you're talking about long-term credentials, that will start with AKI. Okay, so this is you can authenticate. Second thing is where actually the credential are stored. So if you go here in your home directory, they will create a AWS directory. Inside that, they will create a credential file. Inside the credential file, your credential will be stored like this. So you can see you have a multiple profile and your credential will be stored like this here in your this case. Okay. Now, so this is a typically how you can authenticate. Like you can see here, we discuss about you can use your browser to authenticate, or you can use CLI to authenticate. CLI, we have both the options, long-term and short-term credentials. Okay, so when we do red team assessment, we'll see how we can actually authenticate, but just a summarize how we can actually use it. When we're talking about AWS cloud services, there are multiple services are there, but these are the core cloud services. Like you can see, we have a compute that's like EC2 instance, Lambda functions, container services. We for networking purpose we have a VPC, identity and access management we have IAM. For security we have a CloudTrail, CloudWatch. For logging and monitoring purpose, and for storage we have multiple services. So these are the services generally, these are the core cloud services for AWS. Okay. Now let's start with a very interesting point here is called identity and access management. How actually, access management look like, how we can provide the access. Because when you see why it's important, when you see it here in control plane, if you want to perform any action, control plane first check what what sort of actions is authorized to you. Based on authorizations, you can perform the actions. How you can provide the authorizations, you can provide with your identity and access management. So that's why IAM is really important to understand how its IAM look like and how we can provide the access to this keys. Okay, so just okay, so now, so identity and access management is just a service of AWS Cloud, right? That will allow you to provide the access to users, to a group, or to a role as well. So now this is a complete architectures look like. How does IAM work? So you can see we have a users, we have a groups, we have a role. These are three different, or we can say these are the two different. One is user and role, two different identity in AWS. That means using these identity, you can authenticate. Now, user is very simple. You can attach the policy to this user, and in the policy you contain the actions. Again, I'm repeating here. What is happening here is, suppose for a user employee 01, you want to provide any sort of access. How do you provide it? You have to create a policy. Inside the policy, you have to mention these three things: effect, actions, and resource. So these are the basically permissions you have to add it in this policy, and you can attach this policy to user. So user can have the actions that is on that resources based on the policy which is attached to this particular user. You can also attach this policy to group as well, or you can attach this policy to a role as well. So how this is look like? So you can see in AWS you have multiple users, right? All these are user of AWS. That means the user that you created within AWS account. These are not federated user, the user that you created within AWS account. Okay, so these are the user you can see. User have now you can see when you create a user, there are two options. Either you can provide them a portal access that's called console as access, or you can only provide the programmatic access. So that's up to you, or you can provide the both. What happen if you provide them the programmatic access? This will generate an access key ID and secret for you. So you can configure in your CLI and you can authenticate. Second point, if you provide a user a portal access or console access, that means they will generate a username and password. So you can use that username and password to access the portal there. Now, similar like users, we have a groups. Group basically contain a is a collection of IAM users. So suppose if you want to assign a permissions to set of groups like developer groups, you no need to go to each and every user or every developer to assign the permissions. So you create a developer group, and you can add all the developers in that group, and you can directly attach the policy to that group particular. Okay, so this is how you can see all the users are part of this particular group. Last one is called role, which is really important to understand. Let me, I think, so you will get a better idea what I'm talking about a role. So suppose what happened in one case, suppose you have a user, you can attach, this is basically AWS account, AWS services you can see. So you can attach one policy. Let's create this one. So you can attach this policy to this user. Policy means you mention that all the permissions here. So this is basically policy. In policy contain permissions. Very simple. Now, if your user want to authenticate, suppose if your user want to authenticate to AWS, here you can authenticate. There are two ways. One is you can authenticate with your username and password to GUI, or you can use your programmatic access. That means access key. Programmatic access. That means you can use access key, and that you can use it in your CLI. Now, when AWS check, first it will check what sort of permissions you have. So it will check your policy. It will check what sort of permissions you have. Based on the permissions, that will allow you to perform some actions here in AWS account. This is normal case. So in this case, user is just like a identity here. So you will, based on the permissions that is attached to user, you provide the access here. Same thing if you're talking about groups. Group, basically you create a group here. So basically you create a group here, and you can assign a multiple users like user 1, user 2, user 3, and you can attach the policy to that group. Policy means this permission that is contained in this, and this group can so any user want to access AWS services, it will not only check the user policy, but it also check the group policy which is attached there. In this case, user have two permissions. One permission that will directly attach to a user, like similar like this, and second permissions is like this, the which is attached to a group. Okay, this is very simple. Is it just like this is happen in a traditional case as well. Now, what is different here in AWS is called AWS role. What do you mean by AWS role? Now you can, when you're talking about AWS role, you can see it here. Suppose if I suppose this is my AWS account. Please listen it carefully because this is really important. So this is my AWS account. No. AWS predefined set of permissions are role. No, predefined set of permissions are called policy only. So the policies basically contain a permissions that can be predefined or that can be user defined. But role is what happened. Very simple example. Suppose if you have a very simple example, if you have your VM, that means this is a virtual machines, and you have your stories. That means your you can see it's you have a RDS, your database. Okay, very simple example. Traditionally, what happened? This is the normal case. Suppose you have your application which is running on your VM, running on top of VM. If applications want to access the RDS, how it's possible? It's possible we can define the credential of MySQL or any database in hard coded in application itself. So you added your MySQL username and you specify MySQL password. Okay, so you hard coded here in this case. Now, what is the new coming up in a cloud era is that will eliminate. So suppose if somebody compromise these applications and somebody have these credentials, they can directly access the database from there. In this case, role will play a really important role. Now what happened? Suppose let me just okay. Now suppose you have applications, you have a role. Let me okay. This application. Now what happened? Okay, so things that is happened here is, so instead of hard coding the credentials, what you can do, you can create a role here. So role is basically is an identity. Similar like in our user, role is identity, but role can only be attached to a resource. So suppose in this case, we attach this role to VM and we assign permissions to this role. Permission means we assign a policy to this particular role. We assign the policy to this, and the policy means set of permissions. Very simple. Now what happen if your VM, if your application running within a VM like your application which is running within a VM, if they want to access the database in the backend, what happen? They will connect back to. So in the backend, what happened? Because now in this case we have identity here, right? One second, I'll just give it clarity. So basically, what happened? We in each and every cloud providers we have a called STS service, security token service, which is running on 169. That called metadata service as well. 254, 169, 254. Now very simple. Suppose in this case, if somebody want to, or if your VM want to access database, they will connect and they'll see there is a role attached to this one. They will connect to your STS. They'll retrieve the temporary token. So if you connect it, they will get a token, means a temporary credentials. They can use this token to authenticate to your database. So the same token they use to authenticate to the database, and these token are temporary credentials. In that case, what happened? No need to hardcode the credentials in VM or applications. You just create a role, assign the permissions, and that's it. So if any your application want to access it, it automatically connect to your STS service. Based on the permissions, it will basically give you a token. When they will use this token to authenticate to the RDS first check what permissions you have or what permissions this token have. Based on the permissions, you will get a resource access. Okay, any questions here? Is basically eliminating hard-coded credentials. And if you're one VM or if you're one resource, AWS resource, want to access any other AWS resource, and how you can authorize in that case, that's why we introduce, or AWS introduce, AWS role functionality here. But keep in mind that all these things happening within the AWS account. So suppose if you are outside of AWS account, this is the scenario won't work. There is a different scenario will work in that case. But this is happen because of if you are part of AWS account, and this is happen like this only. So you will be part of AWS account or within the AWS only. If you want to access, if your one resource want to access another resource, the role will be created like this. But other part is same, like the policy will be the same, and the policy contain the permissions. Policy similar, like you have a policy that can attach to users, that can attach to group, and that can attach to a role as well. So role is basically identity. We can use it to attach to a resource. Correct. So for any of the AWS resource, you have to first create a role. You have to attach the permission of that role, and all these things. These are scenarios happen in the backend. So this is the this is the advantage of having the the roles there, because in that case your VM also have now your VM have this identity. The identity means role is the identity itself. Initially only user and group have identity. Now in this case your VM also have one identity there. Okay, any questions here in the role? Okay, so very you can also see here in this slide. Yeah, you can see in this case, if you want to access S3 bucket, same like you just need to create a role, attach this role to you any resource, like generally it's compute resource, and then your resource can access the S3 bucket based on the permissions that you attach to this your role. Okay, so you can see and when you go for a role, you can see their trust relationship. Trust means where we can attach this role. So that means in this case you created a role only for your EC2 service, and that means this role can only be attached to your compute instance. You can create a role that can attach to your Kubernetes. You can create a role that can attach to your containers. Lambda function or any other services like this. So this is a typical the concept that we created a role there in AWS. Okay, now last one, we have a policies. Policy means, so you can see we have multiple policies. So policies, very simple. Policy contain a set of permissions. Set of permissions contained in the policy. Now you can see these are the policies there in AWS. What exactly permissions they contain? They contain like effect, actions, and resource. Effect means it's allow or deny. So AWS support both of the policies, allow permissions, allow and deny permissions. Actions, what actions you can perform? So you can perform get, put, delete, all the actions that based on requirement. Third one is the policy contain a resources where exactly you can perform this action. Suppose you can specify any specific VM. That means you can delete this VM only. You can change the password of this VM. That you can restrict to a resource. Or if you put a star, that means this actions you can perform in any of the VMs there. So you can see the statement. This is how you can the policy is designed there in AWS. Okay, and let's move to the last one. When we're talking about policies, there are two sort of policies. One is called inline policy and another one is called managed policy. What is the difference between these two policies? So managed policy is the policy basically you can directly attach to a, so let me just give you a quickly overview of the difference between policy, so you will get a, okay, so suppose if I'm talking about policy, so suppose this is the policy. Policy means set of permissions. It can be one permission or it can be multiple permissions. Now you have a users, you have a group, and you have a roles basically. Now you can see you have a users, you have a group, and you have a role. You can attach this policy to the users, group, and role. Now there are two kind of policy. One is inline and one is managed. Managed policy means this is, suppose this is policy is the policy one, and there will be one unique ARN, uniquely identify ARN. That means ARN will be policy, something like ARN will be policy one. So if it's a managed policy, that means the same policy we can attach to a multiple identity. We can attach to users, we can attach to a group, and we can attach to a role. So this is called a managed policy. Same policy can be applied to a multiple identity. So this is called managed policy. Inline policy, the policy you can directly create it on user specific. Suppose you can go for a user and you can create one policy which is specific to this user only. This is inline policy. Inline policy. That means this policy is only applicable for this user. You cannot attach this policy to anywhere else. This is only applicable for this user. Specific to this user. This is called inline policy. The policy we can attach or we can reuse to a multiple entity or identity, that's called a managed policy. Very simple. This is a managed policy and this is inline policy. So this is you can create based on this particular user permissions. But this is only applicable for this user only. You can create another inline policy for this group. You can create another inline policy for role as well. But there won't be a same, so this policy cannot be attached to this group or this role. But managed policy can attach to a multiple entity. Like you can attach to multiple users. So that's the main difference here in the policies. Now, when you're talking about managed policy, there are two sort of policy. AWS managed, that means the predefined permission which is managed by AWS is called predefined. There is one more called customer managed policy, the policy that is created by a customer only. But these are the part of managed policy only. So you can see it here. If I go here, This is a user, and this is how policy assigned. Now you can see in this case there is a two policy. One policy is AWS EC2 full access. This is the managed policy. That means this policy can be attached to any users, any group. But there is one more policy we created for this user only. This is called inline policy. This is only applicable for this user. This policy cannot attach to any other identity in AWS. Okay, so that's the main difference. So when you do a red team assessment or pen testing, keep in mind that you will see all the policy, all inline and user managed policy attached to a user, group and role. Because sometimes what happen will when we do red team assessment, for our client, we see a lot of time client have a misconfigurations. They do have misconfiguration in their inline policies. They will provide a some additional access to a user through inline policies only. Okay, now this is just a fundamental. Any questions here? Then we'll do some sort of enumerations part to understand how we can do it from your CLI, so you will get a better idea. Any questions here in this case related to identity and access management? Okay, so this is just a fundamentals, and so now we'll start the full practical. So because it's really important to understand the fundamental, and then we'll go for a practical part. So I'm just sharing one credentials with you. That is a service account, or we can say programmatic credentials. You can use that one to authenticate, and then we'll start our red team operation. So once we do some enumerations, understand the this part, and after that we'll go for a red team operations. So I'm just sharing one credentials with you. So I shared this credential in Discord. So how you can authenticate? Okay, so now let's do one thing. Let's go and configure the credentials, and then we'll start. Understand the user that we compromise, what sort of access this user have, how we can identify what sort of permissions that we have, and based on the permissions we decide that what actions we will take it there. Okay, so it's very simple. Just use your AWS CLI and use AWS configure. Here you have to specify the access key ID that I shared in Discord. This is access key ID. When you're looking for ID, start with AKIA. That means it's long-term access key ID. Okay, now we have a secret. I already shared the secret with you. You can use the reason as a US East 2, or you just leave it as default, but you can use this particular reason. I'm just pasting it out. Okay, now let's hit enter, and that's it. Now let's start with, so suppose you received these credentials and you don't know what sort of permissions this user have. Now let's start with these actions one by one. You can also try along with me, so you will get an idea, because these are the steps you should required even if you do pen testing, red teaming, on any sort of activities there. First things that a threat actor is required to understand the compromised credential is belongs to a user or a role, or it belongs to which user as well. So let's see, you can use the command AWS sts get caller identity, and you can see this credential is belongs to a user, and the username is emp00. You can see everything in here is, this is your account id, means AWS account id. This is your ARN, that is uniquely identify ARN that belongs to this user, employee 00. So the credentials that you compromise or you have is belongs to this particular user. Okay, any question here? Very simple. Now what we can do, we don't know what sort of permissions this user have. Any idea? No. So let's make it a graphical way here, and then you will understand. So there are tools as well. We'll use the tool as well. But in this case, suppose we know that the user that we have is just like we compromise a credential that belongs to user. Username is emp00. Now we don't know what sort of credential or what sort of permission this user have. Also, one more thing, if your credential is not valid, you won't see this one. You will see this like a access denied or credential expire, token expire, and all this case, right? So if you get this response, that means your credentials is valid. Now what we are going to do, it very simple step. We are first check what sort of policy attached to this user. How do I do that? Very simple, use command AWS IAM list. Now one second. Now we know that in this case for a user there are the policies there, but two type of policies there, right? One is called our manage policy, because policy contain the permission, otherwise we don't know what sort of access this user have. And another one is called inline policy. Okay, now let's go and let's check. First we'll check the manage policy. You can use command AWS IAM list attached user policies, and then you can specify it will ask you to specify the username as well. Username, we already know the username, we specify it, and that's it. Okay, let me send it to you in this command. So you can see there is one, when you specify this command, this is applicable for manage policy, list attached policy. So there is one policy, the policy name is, the name of this policy is called read only access. And keep in mind that only manage policy have a ARN, inline policy doesn't have a ARN. So there is only one policy which is attached to this particular user, and the policy name is read only access. So in this case we have a policy, that policy name is read only access. Now if you can see, because in managed policy there are two sort of policy, one is user managed policy, one is customer managed policy. If you see this policy, this is, if there is a account information, that means AWS account is created here, then their identifier is here, that means it belongs to a customer, or customer created this policy. If you see like this generic ARN, that means this policy is there in every AWS account. This policy is same like in every AWS account. That means this is a AWS managed policy. Very simple. Don't take it too much of don't confuse it. Very simple. First we'll to check if it's a managed policy or inline policy. So this is a command which give you the idea about managed policy. The user that we compromise, however, there is one read only managed policy. Let's see if there is any inline policies there or not. If you remove the attach command, you will see the inline policy. So there is no inline policy here for this particular user. So that means only manage policy, there is no inline policy, but it's possible that you will get an inline policy here. Okay, now we understand that there is one user that we compromise, which user have only one policies, and that is read only policy. This is name of the policy. We don't know what exactly permission this policy have, right? Now, so we know that. So this is a policy that is attached here. Now what we are going to check it is permissions for this particular policy. How do I do that? So let's go. Let's open a new tab and let's copy this command from here. Don't be confused. So this command will check. So manage policy, there are multiple versions are there. Versions means, so suppose version means, suppose you can change the permissions. So suppose what happened initially, you have a version 1, so you can have a multiple version of one policies, and version is specific. That means you can even change the permissions, you can upgrade or you can degrade the permissions. You can add the additional permission and you can remove it. So first we have to check uh, the current version of this particular policy. So you have to specify this one. So first we will see the version. So this particular policy, there are multiple hundreds of versions there. So you can see there are 98 versions for this particular policy. Why? Because this is the AWS managed policy. So time to time AWS change the permissions for this particular policy. If it's a customer managed policy, that is also possible that customer can change the multiple version of the policy. Initially they thought, okay, 3 permissions will be sufficient. Later on they realized that they can add one more permissions or they can remove any additional permissions there. Now what is the point here is, what is the current version? So you can see default version is this one. So 98 is the default version which is actually using it. So you can make it a default to any other version. That will allow us to even escalate your privilege. Suppose in other version, or we have additional permissions and we have options to change the default version. If you make a default version to 97, you can escalate your privilege there. Okay, so first we understand the versions. We know that this is these are the versions for this particular policy, and this is the default version we have. This is the default version. Okay, now what we, as of now, we don't know what actually permissions have in this particular version. So we know that we identify the policies, we identify this policy. Now we identify the version. The default version is called 98. Default version is v98. Let me. Now what exactly permission this contain is, now it comes to picture, is called permissions. Okay, now let's go here and let's exactly see the permissions here. Okay, let's close, let's open a new tab. Now you specify policy ARN. I'll take it policy from here. Let's take it from here, ARN. So this is the policy ARN. Version we have, so you can check the permissions of any version. So let's say we have v98, version 98. These are the permissions which is there in this particular policy. Permissions, we already know it's based on effect, actions, and resource. So effect means this is the allow permission. These are the allow permissions. Actions means they can do get, list, these operations there. So you can see when you have a read-only permissions, you have only get, list, and describe permissions. You don't have a put, delete on any other permissions. Why? Because this is a read-only policy. You have only get, list, or describe permissions here. You can see get, list on all the applications. So this is how you can see all the permissions. So that means the user that we compromise have a read on it. So you can see mostly we have a get, we have a list, and we have a describe. That means it's a read permissions we have on AWS account. So this user have only read only permissions on this particular account. That's how we can create a attack path to any user that we compromise it. Okay, any questions here? Okay, same thing you can do it. Suppose this is the user that we already know. Okay, now if you want to see the any other user, like let's say policy for if you want to see the basically inline policy, let's say you can see the policy for any other user, EMP01. You can see EMP01 have this particular policy, that's inline policy. EMP00 doesn't have any policy that we compromise it, but there is one more user which have inline policies. You can see, and there is no ARN. So this is how inline policy look like. If you want to see the actual permissions of this policy, so you can use this command to see the inline policy. You can also get, because we have a read only right? So we can do anything there. And how you can actually get the inline policy permissions, you can use this command. One second. Now you specify the username, because in manage policy, I only specify the ARN. That means manage policy is the policy you can attach to any identity at a time. But inline policy can only be attached to a single identity at a time. So this policy attached to this particular user, let's say you have a user and this is my policy name, and let's use it. This is the permissions that is there in this inline policy. So keep in mind that this is a suggestion from our end, or we can say tips from, because in our past RedTeam experience, we not only just check the manage policy, but we also check the inline policy and check the permission. So you can see same like effect means allow, actions mean S3 star. That means we can do any actions on S3 bucket, like S3 create a bucket, delete bucket, update bucket, or even do any action on object as well. And when you say resource means we can do these things on any S3 bucket which is there in AWS. Okay, so this is how we can identify it. Any question similar, like we can do a lot of things there, but this should be a generic thing we should require, and we understand that how we can get these informations. How we can enumerate a user account, how many users are there, which is like if you go for a slide as well, you can do that one. These are the very simple. Or what we can do, you can directly just type the command here. Suppose if you want to see all user account, you will see all users here. But keep in mind that this will give you the information of all IAM user within AWS only. It won't give the information about federated user. So all the users which is part here. Suppose this is the EMP. You can also see it, users, you can also see the groups, you can enumerate a lot of things there from your AWS CLI. Like you can use the same command, list groups, list roles, how many roles are there. So these are the group, these are the roles. So these things we'll discuss when we are doing these operations there. But these are the fundamental we should have an idea. Very simple. We have users, we have a groups, we have a role, we have a permissions that attach to users, to group, to a role, and we have a policy. Policy we can contain the permissions there. Difference. Okay, somebody asking difference between list user policy and get user policy. When you see the difference when you looking for this operations, if you see get list mean it will list it down, it all the policies that is attached to this user. Suppose in this case it will list down all the policy attached to users, attached to a group, attached to a role. It won't give you the exact permission, what exactly permission is contained. If you're using get operations, then only you will get these things. So get operations will give the actual permissions. This will just give you, suppose you can attach a multiple policies here. So list will give you all the policies here. Get will give you the actual permissions. Just like in a bucket, if you use list operation, it will give you all the buckets there. If you use list operation on specific bucket, it will give you all the objects within this bucket. But if you use the get command to access any bucket, access any objects within that bucket, you have to use the get command. Uh, Second question is, so we can enumerate federated account as well. So basically, when you're talking about federations account, keep in mind that in AWS case, I think I'll discuss when we do RedTeam operations how actually the federations happen in the AWS side. All the accounts, everything which is there in Azure side, not in AWS side, but there is one we can say permissions are created in AWS that will allow you to assume this role. So you will get the idea when we discuss about assume role scenarios. I think yeah, that will the best way we can provide this one. But you have options to enumerate as well. Okay, any questions here? Because now we'll start our actual red team operations. So please keep in mind that any questions here, just let me know, because once we start our red team operation, we'll start from our initial access to our data exfiltration. We'll do lateral movement, we'll do privilege escalation, all these things. But before that, you understand why we are using these things, what exactly we are getting to execute this command. Okay, any questions here? No, I think what we can do, just let me know if anybody have any questions here. We'll go for a 10-15 minute break. Meanwhile, I'll just start a lab for you, and then we'll start our actual red team operations, where we use to get a initial access, enumerations, privilege escalations, data exfiltrations, lateral movement, everything we'll do it here in one hand. But before that, if anybody have any query questions in this case, yeah, we'll discuss. Don't worry about this one. When we see the assume role scenario, we'll discuss about how actually we can do it this case. Because in AWS, Federated access is provided in a different way. Federated provided in terms of assume role scenarios. So that we'll discuss when we start the RedTeam ops there. Don't worry about this one. We'll consider at this point. Okay, I think we'll go for a 15-minute break. Meanwhile, I can start the lab and then we'll start. Please make sure you install the tools which is mentioned there in this slide. This one. Yeah, for Azure, at least you install this AWS. You install at least these 2-3 tools so we can actually use it in our RedTeam operations. That will be required, So you can install CLI you already have. You install this Pacu module as well. These are the only two tools we require for AWS Red Teaming. And most of the thing we'll do with CLI, but tools is just like, we understand the conceptual things and you can use it even tool to do the same things that we are doing with the CLI as well. Pacu and AWS CLI, right? These two tools you need to install it. Meanwhile, I'm just setting up the lab for you and then we'll be back. But if you have if you have any questions, please let me know. Please make sure you're ready with the tools so you will get an idea about what we are going to achieve it here. Any questions? Okay, we'll go for a short break. Meanwhile, I'll just start the lab. Okay, I think so we'll start our actual RedTeam operations here. Please make sure you install both the tools, Pacu as well as AWS CLI if you haven't installed yet, and we'll start our operations. Okay, so if anybody have any questions regarding this thing, because whatever we discuss about will be utilized here in our red team operations. We'll see how different attacks vector on AWS side, how we a threat actor can identify if its permissions are excessive or they provide in a or how they can actually use those permissions or misconfigurations to take advantage of perform multiple things like privilege escalations, lateral movement, or any other things. Okay, so I think we'll start from here. So this is the second part of our second module, like in AWS. Here we will do a red team operations. First, we'll discuss about different methodologies that we follow when we do red team operations for our client environment on cloud, AWS cloud, or any other cloud providers. Then we'll discuss about what will be our objective. Right? When you do assessment, there will be some sort of objectives behind that assessment. On based on objective, we'll achieve that one, and we'll follow that particular path. And then we'll see the recon part here. Sorry, the full red team operations. Now let's start with one by one. When you're talking about methodology, generally there are two standard or there. One is called MITRE ATT&CK Cloud Matrix. So this is a generic one. So the technique is not specific to this particular misconfiguration or attack, but these are the generic one. You can also follow if you do a threat hunting or if you're doing any any sort of threat intel or any sort of other activities. We can also follow this particular techniques there. Even sometimes we use these techniques to do a red team operations there, but these are the very generics there, right? We'll discuss about a cloud specific, that is specific to AWS cloud. It's like you can see phishing, valid account, and all these things are very generic. When you're talking about specific to AWS, we have to think in a different way. So MITRE ATT&CK framework for the cloud won't give that specific things for AWS. Now, this is the another methodology that we follow when we do red team operations for our client side. So this is our own the methodology that we follow. So you can see here when we start execution of a red team assessment, we'll start with recon because cloud have a huge attack surface. There are a lot of services are available which is directly publicly exposed. So we collect those information, we collect those services, do multiple things there, and once we get those things, we'll start with getting the initial access by any of those things that we collect from during our recon phase. Suppose if we collect a leaked credentials, we collect some sort of valid credentials belongs to a user in dark web. There are multiple ways out there. So once we got those credentials, we get these credentials to authenticate to the AWS. So once we get the initial access on AWS account, we'll start enumerating things. Just like we saw our last sessions, we compromise EMP01, like we receive or we got the credentials. Now, how we can enumerate what sort of permissions this user have? So you can see that this comes under enumeration part. Now, one more interesting thing is here is in the cloud side is suppose if you allow to create a backdoor, there are two different areas that you can create a backdoor. One is the traditional, you can create a backdoor as an operating system, like you can add a SSH key, you can add your user there, you can add in admin group. That's one way. Second thing, what you can do it, you can create a backdoor in cloud as well. So you can use the cloud specific services. like Lambda functions. You can change the code there. We'll discuss like different services are there, but these are the two options are there specific on the cloud side. You can create a backdoor on VMs, which is hosted on cloud, AWS cloud, or you can take advantage of cloud specific backdoor, the services specific backdoor there. Same thing is only also applicable on privilege escalation side as well, because it's not just like in a traditional case we escalate our privilege. If it's a Windows or Linux based system, we just only escalate our privilege on a host or Windows or Linux based. But in cloud side, you have to perform the privilege escalation on both the areas. One in on Windows, Linux or operating system side, and second one is cloud specific service privilege escalations. So once you escalate your privilege, what you can do, you can request for a request for a credential or hunt for a credentials, we can say. So there are multiple locations are there where actually credentials are stored. It's like your secret managers, where actually your credentials, your SSH key, everything will be stored there. Other locations are like application source code, storage bucket. So multiple areas are there where credentials are stored. And the important point, just like we discuss about the roles, we discuss about HTS. So if you are there in compute instance, you can even retrieve the credential from metadata there. So that is also part of credential access. Now, once you have a credentials, that is, you can use those credentials to access highly targeted, or we can say to critical resources there. That is part of a lateral movement. So you can go for another VPC, or you can even laterally move from your CLI to the portal access, or control plane to the data plane access. It's basically depend upon how you're performing the lateral movement. Once you do a lateral movement there at the and you're based on your objective, you can perform multiple impacts there. Impact generally we do just like data exfiltrations is one. Second one is encryptions and destructions. Encryptions for ransomware, if you want to simulate any ransomware kind of activities, you can do it there. Or if you want to do any sort of destructions like deleting the things, so that will also possible there. So based on the objective that you have, you can create an impact there. So this is the methodology that we follow when you do red team operations, specific on the cloud side. So these are the privilege escalations and persistence are we have multiple areas in the cloud. Other part is like we'll follow like a traditional one, but the techniques that we use it are different than that we follow in the traditional one. Okay, now important point here is what is your objective. So as we already discussed, when you're talking about single cloud account, that means single AWS account, your objective is to just become a root of that on that particular account. That's it. But if your account is part of a organization and you are just a member account of that organizations, definitely your objective is become to admin on basically admin on master account. So if you have a master account access, that means you can compromise or you have access on all other child account. So it's completely depend upon how your organization structures are there. But mostly if you do red team assessment of any organization, even small to a medium and large organizations, they have multiple AWS accounts and all are connected to master account. So that means your motive is to become the root on master account. So you have access on all sub-child account. You can have objective like exfiltrate the data, perform the ransomware activities. You can also do the crypto mining, all these things they are in AWS, in this particular operations. But these three things are really important, that is highly impactful for organizations. Like ransomware also now these days are lot of people are moving doing the simulation on ransomware activities there. Even from threat actor point of view, they steal the information, they deleted the backups and all these things. We'll see how it's work, but yeah, these are the things can be part of your objective. Now let's start with the actual red team assessment here. Start with the recon phase. Uh, okay, now let's start with a recon phase here, and then we'll see how it works. We'll discuss whatever point topics that we have, just like assume role and all these things. We will get to know while doing these things. So we'll trying to do all these things by doing all these things. And even if you have a questions, we'll discuss in the after that. Okay, now suppose when you're talking about recons, so what we are going to enumerate is we are going to enumerate the informations that belongs to the particular organizations on AWS specific. You can do it with a DNS records as well, like where your S3 bucket, where you're exactly your DNS point like there. Suppose if you are using any subdomain where it's mapped to this particular account, where your mail is hosted there, what sort of other services are using it. Suppose if you're using VM, which is running the where you running the virtual machines, and you pointed out to the A records, you can also check that one. Second point, we also check the subdomain map to this account. Subdomain mapping means most of the cloud services have a subdomain, mappings there. Just like S3 bucket, they follow a proper naming conventions. And if your organizations have one unique, keyword that is belongs to your that is seems like belongs to your organization, so you can also enumerate this thing by from Ocean Techniques. We have a leaked credentials like in GitHub or any other source code repositories there, compromise credentials, and we can also get the employee details to for phishing or any other things there. Now let's start with this one. I think there's one more thing pending here. Okay, let's start with just a recon part. So in this particular recon case, we are using one tool called Cloud Enum. I think it's there. Yeah, this tool. Just simply just clone this particular GitHub repository, and then we'll see. So let's sit. This. Let's see if I can. So my screen is visible to you. Like it's or I have to just. No, actually this code is not. Let me see if I can do it here. So I'm just go to. We'll start with the assistant. So what we are going to do it here is we are going to enumerate. There's one tool called Cloud Enum. It's not specific to AWS. You can enumerate any services which have a subdomain map to that organizations. I'm just using Cloud Enum. Okay, now how does it work? Let me go to here. Okay, what we are going to do it here, we want to check if a particular organization, atomic nuclear, or you can use the keyword of that organization. Suppose organization name is Apple or Google, you can use that organization name. But in our case, it's atomic nuclear. So what we are going to do it here, I'm just looking for any resources specific to cloud that map to this particular or that have this particular keywords in their subdomain. Okay, so this is the command. You can use it for your reference. You can use cloud enum minus k, that means keyword, and it's atomic nuclear. So you can see it will check AWS, Azure, and GCP, the services which have a subdomain which have this particular keyword contains, like atomic nuclear. It will say take some time, but this will really help in your RedTeam assessment, because you understand, you get to know that if they are using any S3 bucket, any other sort of services where we have this particular subdomain. Just take some time. Let's wait. So what you can just go to this particular this one. We don't have any information as of now. Just I'm just looking. So you can see from AWS side, it will see open bucket, any apps. Just like in our case, we are using SSO. So most of the organization definitely they are using SSO. So they will give you this thing. Azure side, a storage account, blob, virtual machine, web app. These are the information you can get it without interacting with any organizations. So you can get the information with this tool. This is all the enumerate all publicly resources there. Now you can see there is one application found on this particular. We know that this is the URL, which is we can specify federated. This is a SSO URL, right? Where you can specify these things. Now let's go it here. Yeah, it will take a lot of time. So we are not interested in Azure and GCP as of now, but just by looking here, you can see from GCP also this will give a lot of information there. So if you do any sort of assessment, pen testing, external pen testing, red teaming, please make sure you use this tool. This will really helpful for your assessment. You will get this idea. Like you can see it here when I run it for this particular keyword. Here you have to specify your organization's keyword that your organization use. In this case, we found that one. Now, what you can do it here. Let's close everything here. So this is the SSO URL that belongs to my organization. Not every time, but it's not necessarily belongs to your organizations. But this just an assumption that it belongs to, because the keyword generally organizations are using keywords for these cloud resources. Okay, now let's go and log in it. Now what else do you need? So in this case, this is just a URL we got it. Sometime you will get a open S3 bucket. Sometime you will get any other, or any other resources there. Now let's. Okay. Now what we are going to do it here. In second case, we identify this one, this particular SSO URL for that belongs to this organization. Now, if you identify it, how you get basically initial access there. So in this case, we are using assume role scenarios, but not every time you have to follow it. A lot of time you'll get the credentials from bucket storage. Sometimes you have to perform the adversary in the middle attack and advanced phishing attack as well. But in this case, we are just assuming the scenario that we have a credentials that belongs to an employee, and we know that where we use it. So suppose if you have a credentials, employee credentials, and we know where we use it, we can use it here. So I use the same credentials that I already shared with you. So just try to log in it, and yeah, you authenticate. So this is the assumption I took it here, but not every time you have to follow the assumptions. Sometimes you get a initial access by exploiting public facing applications. Suppose you from the cloud enumeration side, you enumerate that there is a VM running there on, or there is application running there, and you found RC or SSRF. You can retrieve that temporary token. You can get it from GitHub and or any other sources. Even sometimes you can perform the advanced phishing attack like adversary in the middle attack or AITM kind of things, or you can or you can perform some sort of SSO device code phishing attack as well to get these tokens there or get the credentials there. You can also compromise employee credentials, and there you can retrieve the tokens there because it's stored there in your device and some of the default configuration here. In this case, I assume that we found the credential from the dark web and we can use it here. So now you can see I'm successfully able to authenticate here to this particular user. Now what we are going to do it here, let's, so if you go here, You can see I have only read only right. I don't have any other rights on both of the accounts. So let's take this account. So there you have two options. You can directly go to management console, but in our case, what we suggest, try to use CLI or tools as much as possible. So you will get a clarity instead of GUI. What we are going to do it, we are generating a temporary token here. Just click on this command line in programmatic and generate a token here. Okay, now let's follow. So these are the temporary token. This is stored. This will be valid for a short period of time. Let's copy this one. Manually add a profile to your AWS. Let's copy this one and let's change it here. Okay, so let me open it. Let me open this one and I can add to my. So where exactly credentials are there? So you can go here in your root directory. You can directly go to your root directory. And you can see it here. It will be there in. So let's go and configure their credential directly. So in our case, it will be there. This particular user directory, there will be a folder called AWS, and you can see credentials. You can go for here. So let's say if I use nano credentials, let's see if you're in the same directory. No, okay, I'll just change it here to use AWS. See, AWS. On this, so you will go your user home directory and you can see there are credentials there. Use and you can change the credentials from here. So just paste it here. So how does it work? You'll just directly paste it. These are the short-term credentials. You just directly paste it here. Uh, this one, you access key ID. From here, you have access key secret. Oh, one second. I think they will take it. I'll copy from here. That's the problem here. And I'll just open in Notepad. So I'll paste it here. So it will be like this. Let's change this one to use anything. Default it here and just paste it there. And just paste it to your machines where you have a. Let me open it again and let me change this whole scenarios. So you can see I have access key ID. I think it's happening because of this one. Let me open it. Yeah, you can see I have access key ID, I have access secret and this one, and then say. Okay, that's it. So this is how you can configure your short-term credentials. You just need these things to configure your short-term credentials. Why I'm saying short-term credentials, because in short-term credentials we have a you can see it starts with ASIA, access key ID, and we have this access token as well. In long-term credential, it start with AKIA, and there won't be any access token attached. This one. So access token have a limited time frame. It will be expired. Now let's see belongs to which user. Okay. So you can see now actually I'm logged in as a federated user, and you will see like this in this case. That means this is the, if it's a federated user, this will be like this only. AWS Reserve SSO, your role name, and it will be like this. Your unique OIDC ID, I think, and then your employee details like email address. Any questions till here? How you can, like, we know that if you have a long-term credential, you can use AWS configure it, or you can directly specify with access key ID and secret. But if you have a short-term credentials, you can directly paste it here. And the difference between here and there is, like, here you can see simply if it's a federated user or if it's a inbuilt user. In federated user, you can see you will get it like this: AWS Reserve SSO in each and every case. Okay, now what we are going to do it here. Okay, what we did it, suppose initial access we use assume based scenarios that we compromise the user credentials. Once we get access, what we are going to do, we are going to enumerate, perform authenticated enumerations. First, we are enumerating what sort of access we have, and then we'll see any other services we can do it here. So you can see it in this step. We are going to enumerate is, first we use the credentials to authenticate, and then we are going to enumerate it. So we authenticate in this particular URL. We use our employee credentials. We configure this one, our employee credentials, and you can use it. Okay, so this is how you can configure your credentials. Same thing, suppose if you're using Paco, so Paco is a utility that will, it's basically your the tool which will use to perform multiple things in AWS side, like enumerations, privilege escalations, persistent, lot of things are there. So you can use this, you can configure this credential in Paco as well. So we will use tool as well as we will CLI to do the same operations there. So you will get an idea about what is actually conceptual things happening there and how you can utilize a tool to do this data operations. Okay, so let's create a new session. So you can see there are multiple sessions are there. I'm just going to create a new session. Now it's automatically take my this one. You can also configure the credentials, but and it will, otherwise it will take automatically credentials from your system as well. If you want to set you have to set like this. You have to set the key like this as well. If you haven't specified in your AWS here in this particular file, you have to specify like this. If you already specify, it will automatically take from your your credential file. Okay, now what we are going to do, let's perform. The first and important thing is we have to going to perform, there are multiple modules are there. So you can see there are multiple modules are there. First we are going to perform the enumeration module, just like same like we did it with the CLI. Let's do with the Pacu. What exactly, what credentials you have. So you can use enumeration module, run IAM. So you can use the module name here. I'm just copying from here. sometime it will give. Let's see if I'm able to use it, or you can even set the credential. Sometime it's happen if you use that one. Let me set it. Let me see if I'm able to do that. We use the enumerations credentials. No, it getting some error. So let's set the this key here directly here. So we can use Pacu set key. Just setting the keys there. We can use the same EMP01. No worries. Okay. Access key ID, you can set it like it is the same access key ID we can retrieve here. So let's copy here and paste it here. Same, we can also paste. So you can create even new thing, new sessions, and you can copy from here and you can paste it here. And same access token. So let's copy here and paste it here. Okay, so let's paste it here. All these things. The key is already set. Now we already done, and let's see if I run the this one again. Ah, you can see. So the same thing we can do it with the tool. Same thing we did it with the CLI. And if you see, who am I? What exactly? It will automatically do the operations. We'll see what sort of permissions you have, what you can do it there. So you can see everywhere I have these permissions there. Okay, I think we have a limited this one. So otherwise it will give you like this. So when you use this command, this module, it will do in a backend like same thing we did it to get the list attach policy or list inline policies. All these things we'll do it in backend, and you can see this is a role which is attached to this one, and you'll see all the permission for this particular role. Okay, now so once you get all this informations, you can even use it. So let me use this in my this one. So this will give you idea. Let me set in this machine. So we'll use both the things. Let me set this data. Okay, I set it there. So I setting in my local. This is the attacker machines where we have a pack2 running there, and I use one more machine. That's my normal machines where we set the credentials. So same if you see. Okay, so you can do the same thing with the tools, and you can do same thing with this particular CLI as well. Yeah, that's really good questions. So Abhijit asking questions. This is an employee 01, a user, but role can only be attached to a resource, and how it's come to has this role. This is really good questions. It's happened because of the assume role scenario. So initially, what happened when let me this one. So initially, what happened? Uh, you have a role. Sorry, one second. You have a role, and you can create. You can attach this role to. This is a role. You have a role, and you can attach this role to. You can attach this role to AWS resource. right? Like resource, any of the resource, VM or any of the resources, right? This role you can attach to any of the resource, right? But but now the thing is there, this is the main motive of this thing. But if they provide a cross account role, a cross account access, suppose this is possible on this single account. This is AWS account one. But as soon as we have a cross account things, there's like AWS account two or federated user. Federated user means identity of any other account. In that case, what happen? You have to, if you provide a cross account access or federated user access, you in that case also you have to create a role, and you have to provide in an assume role scenario. Assume role basically, so suppose if you check any of the role, what do you mean by assume role? Very simple here. So suppose this is a role. Let me, I think that will give you better clarity. Suppose this is a role we have. What do you mean by assume role? Assume role means who can access this role, who can basically assume this role. So you by default or generally it will be the resource in a first phase. Initially, this they created a role for a resource only. So and resource is specific. Just like if it's a VM, you have to specify here that only VM can assume this role. If it's a container, you have to specify that only container can assume this role. Recently, so now what they allow, you can also assume the role to any cross account users, or third one, any federated user. Now role they define is to use for a resource, but now what you can do, you can use this role to provide access to a federated user as well as cross account AWS user. That's why in this case, this why the user which is part of this account can use and can utilize this particular role if they are allowed, if they are supposed to allow to do this thing. So that means, yeah, correct. Even federated user also assume this role. So if you provide a cross account access, that means, or if you that means you have to use the role. By default, if it's a user, you can directly, if it's a user within the same AWS account, you can directly provide a permission here, right? But if it's a cross account user or federated user, you have to create a role and then you have to attach a permissions or policies here. Very simple. If it's the same account user, you can directly attach the permissions or policy here. If it's a same account resource, you can create a role. But if you want to provide a cross account user to access or federated user to access, you have to create a role and then you have to attach a policy to this role. Okay, so that's why this is a federated user. That's why there is a role attached to this one. Now, just things you can see it here. In this case, this is a user account access, and which is basically how you can identify it's a federated access because of this one. If directly you can see user, that means it's inbuilt user of this particular account as well. Okay, now let's go and let's see. Very simple. What we did in the last demo phase, we know that what sort of access this particular user have. Now in this case, we have to identify what sort of access this particular role have. this is a role they created like this because it's a federated user. That's why they created a role. If it's the same account user, directly they provide access. If it's the same account resource, directly they do have this one, a resource access. Okay, now if you want to see, let me give you to, we can enumerate with our CLI and then we'll see with the PACU as well. List attached and then you have to specify like this. 1 second. List attached policies. 1 second. Just a second, just a second. I'll just let it go. You have to specify this full ARN here. 1 second, I have to change this one as well. Let me take this look from here. So you can do it from here. List roles. Just a second, I think. Assume role scenario. Just a second, I'll just think. Let's take a closer look at PACU. Then I'll just do it. I know once it's done from this side. So what we are going to do it here. Now you can see. Then I'll show you how it's work on assume role scenario when you are going to enumerate with CLI. Very simple. You configured. You can see you configured your access key ID and secrets here, and then you can use the command to get the to get the all the permissions which is attached to this user. So this is a role, you can see it here. This is the information about this role. Now what we are going to do it here, it will be there. So the PACU will store there in data folder all informations. Now what we are going to enumerate is, if you check the who am I, it will fetch in the internal database and it will give you the what actually access you have. So you have if it's you have only read only access on these particular resources. So you can see all the access, you will get it there. It is stored there in a local database. So these are the command you can use it. First you have to set the key. You have to set the else's for this particular key, and you have to set, if it is temporary token, you have to use it. This is just default command. First you have to run it, which will automatically take the credentials for you, and then you have to perform who am I, which will give you the what user or what permissions you have, and what what are the permissions you have and which users or role you compromise it. Any questions still here? Any questions? Anybody facing an issue? Just try to check it. You can see the command here. Command reference is already there. First set the key. First set the key. Then you have to run this command, and then you can use this particular. Okay, you are facing issues with Paco. Uh, what exactly issue you are facing it? Okay, anyways, so if it's not working, no worries about this one. I think so. Basically, you can also do the CLI as well. Try to understand what we are going to achieve it here. So suppose if you configure, a temporary token here, you can do it with the Paco. It's very simple, but try to understand the conceptual thing is here. First, you check what this token is belongs to. So very simple. AWS STS get caller identity. Now you can see this is belongs to a user or a role. By simply looking for this one, you can see this is belongs to this particular assume role. And when you have this particular scenario, that means this is belongs to a federated user. So you have a role, and in the backend you have a federated user. So this is a user which have this particular role, and this credential is belongs to this user, which is attached to this particular role, and which is attached to this user. Now generally what we are going to have, the second point is we have to just want to check what exactly permission is attached to this user or role. So this is a role, because you can see the assume role. If you see it's a user, that means you can see the list of permissions belongs to user. If you see the role, you can see list of permission belongs to this role. So what we can do, AWS IAM list attach role policies, because in this case we have a in this case we have a role, not the user. You can also directly see it here, and this is a federated, the role they will created for this federated user. So now you can see role name. You can use it in Paco as well, but in Paco the problem is you don't know actually what is happening in the background. They will give you the result, but you don't know, so it will better to use the CLI. This is my role name. How you can identify it? This is simple. This is your account, this is the role, this is your role name, and this is your federated user. So federated user have access on this particular role, and the role have directly permissions. So if it's a federated user or cross account user, always remember you have to check the role here. So now this is the full role. Let's see what permissions we have. Let's try to run it. Perfect. So you can see this role have this read only permissions, and then you can the read only policy, and then you can see the permissions there. So you can do the same thing with CLI as well, but for CLI you just understand what we are going to achieve it here. Pacu, we did the same thing. We set the key, we run this im enumerations command. What it does, it will first check you have what sort of user or role that you have. Second one, it will check what is policies inline or manage policy attached to your user or a role. And then if you use the who am I, it will give you, okay, this is a role, this is a user that you compromise, and these are the policies there. Correct? Any questions here? This is really important because when you're talking about user access, enumeration is very simple. But but organizations, they are using federated identities, so you will every time you will face these kind of scenarios. So even if Pacu is not working, you can do it with CLI. Just use this credential here, run it, and you have to check. This is just a managed policy. You have to also check the inline policy. So there may be possibility. How you can check it? List simple role policies. If it check if there any policy for this particular role, there is no inline policy, only managed policy is there. Pack will do all these things automatically, so you won't get a what is happening actually in the background. Okay, now what next we are going to do it here? We identify that this user only have a read only permissions. The same thing we get it from here, and same thing we get it from our CLI as well. Now what we have only options to enumerate. So let's enumerate the So what I did is, let's enumerate the virtual machines, if there are any VMs are there or not. Okay, so you can run, if you want to run any module, you have to just use command run, and you have to use this one. So suppose if you use run, and if you use uh, if you directly run it, it will, if you need help, it will give you all the modules which is there. So how you can run this module, or how many modules are there. So suppose if you want to see help of any of this module, you can use this module name. So in this case, I'm just using a run ec2 enum. It will enumerate. It will enumerate all the ec2 instance. You can also specify the region. Otherwise, it will enumerate all the regions. So you can see, and same thing you can do it with CLI as well. List instances. 1 second. So if you want to see the any options there, you can see all the options which is available there. Each and every command you will see it here. You just need to specify AWS and it will give you the. Any questions here? So this is how, see the result, what we get. Okay, so you can see these are the regions it's enumerated. They found total 2 instances, and these are the IPs. So the data which is stored there in this particular directory, there will be one data directory which is created here. So all the data related to this one will be stored there in this directory. So let's copy this one. 1 second. So you have to go this particular directory where it's there in. And then you'll see. how many we have. The current sessions, I think that was for demo, I think. And we have all the informations here. Downloads, and then you can use this. So you can get the IP address like this. Okay, so this is how what we did it. We have read-only access. You can enumerate anything, but we are going to enumerate the EC2 instance here. So same thing you can also do with CLI as well. You can use AWS EC2 describe instances. So all the instances will be listed here. So you can get the information about instance like this. So you can see this is the key pair we use it. This is the private IP address. This is the public IP address of the instance. And there is instance profile. That means the role which is attached to this instance is this one. And you can see there is, so this is the public IP address for one instance, 90. And there is, see if there any other instance. There is one more instance is there which have this IP. Okay, so this is how we can identify the instances are there. Now what we did it, so we don't have a access, we just have a read-only access on AWS instance, right? Very simple, we have only read-only access. Now what we can do, we identify there are two different IP address. These two IP addresses are there. What we are going to what we will do it here, we'll try to see if there any port is exposed to the public. You have two options. One is you can go for a security groups and you can see if there is they allow any port which is exposed to the public, or you can use the nmap to directly do this scan. So I'm just using nmap to just check if there is any port is exposed here. Okay, so let's this one, let's change the IP address of both the public IP address here. So one is 3. You can also try along with me. So you will get an idea what we are going to achieve it. Initially, we don't have any access. We'll get a read-only access, and then we'll enumerate a lot of other thing internally. We identify there is two IP addresses belongs to two VMs. Let's see if there any open port exposed to the public audience. This is the one, and there is one more 3.145.82.152. Let's specify 80 port as of now. One second, I just check if internet is there. Internet is there. 3.128.19.250. Let's do it. Yeah, I think this is a filtered, and let's do check. I think we have to provide the space here. Okay, so this is a pattern generally we follow when you do these kind of assessment. We identify that there are two ways. One is we have read-only access. We can go for each and every instance and we can check their security group, and then we get the idea. Okay, what are the port is exposed to the public. Second thing, you can directly do nmap on all these public IP address. So we did it for these two IP address. This is the one and this is another one. And we identify that there is one of IP address have this IP address have public IP. Oh, sorry, port 80 is exposed to the public. Let's try to use it. And any questions here? Let's try to use it here. This, let's see if it's anything is running. Yeah, you can see there is one application is running there in this case. Any questions still here? What we did it? We first we enumerate, we did OSINT, we enumerate there is this is where we can authenticate. This is a SSO URL there. We assume that we got the credentials of a user or employee. When we got an initial when we authenticate there, we use the temporary key. You can use the portal access or you can use the CLI access as well. I use the CLI access, and then we identify we have read only access, so we identify VMs are there. We identify the VMs are there and public IP address. Now you have a read only access, you can also enumerate any other things. So if you are using Pacu, it's very easy to enumerate a lot of things there. But if you're doing a stealthy way, generally we prefer to use AWS CLI. Okay, and once we get the IP address here, so you can see we have these IP address. We can check their security groups, or what we can do, we can check, we can directly do the nmap to identify. Yeah. So you can see there is one IP address that is 80 port is open to public audience. When we try to hit it, and yeah, we get to know this. Okay, this is there is one application running there. So for simplicity, we directly use the command injections here. You can see we can execute the commands there. Now what we can do it here, you can take a reverse shells and what, so if you identify here, if you're looking for even CLI, you can see what is the IP address, this one 152. This is the this instance where we have a 150. This is the this instance 152 IP address. There are two different instances out there, and this instance have this particular role attached to this one. Because keep in mind that first you'll check what exactly role is attached to this instance. So you can retrieve the temporary token, or you can come if you have a RC or SSRF are there. So you can see there is one role attached to this particular VM. Now what we are going to do it here. Next step, what we are going to do here, exploiting this public facing application and retrieve the temporary token here. Okay, so temporary token, it will be there in their metadata. So what we can do, we can use like call command 169. So all this stuff, keep in mind that is step by step will follow. We have read only access, we identify the VMs, we identify the federated roles are there, and now you can use it. So let's use latest. Then let's use metadata. And then we can use it IAM. You can use security credentials. Why we are interested is here because we already know that there is instance and there is a profile role is attached to this instance. If this is not the case, you don't have any other access. You just have this VM. You can compromise the VM. You can do, or you can, basically download some malware there. You can do some crypto mining things there. But you cannot go further if there is no role attached to this VM. And you cannot retrieve the temporary token. So let's copy security credentials here, and you can see easy to read only role is there, the same role that is mentioned here. Okay, now let's use it. So you can see what is happening in the background. It will connect to the STS endpoint, metadata endpoint, and it will retrieve the temporary token that belongs to this particular role. Okay. Now we know we have access key ID, we have a secret, and we have a token. Let's again configure it in CLI. So how you can configure it? Let's open a notepad and then credentials. So this will open this one. So there is one more profile where I'm going to set it. Let's use it as a let's say VM. Make it as a VM. What we are going to specify first, access key ID like this. You can also set in your PACU as well. Then what we are going to, we are set in access key ID, create an access token. 1 second. So like you can set it there in yours. Right? Access key ID, where we get the access key ID, you can see the access key ID like this. Access key secret, you can copy from here to here and it will work. And then we have a token. This is the token. Let's copy the entire token from there to here and configure. This is how you can retrieve the temporary token and you can configure your CLI, your credential here. So you need, if it is a temporary token, these are the 3 things you required. Save it. You can again, you can do the same thing. You can again set in your PACU. You enumerate again IAM permissions, who am I, and all these things. You can do it the PACU as well. But what happens if you use just a tool? You don't know what actually happening in the background. So that's why I use it CLI a lot here. But feel free to use the tool as well. Now you already configured, and in this case, I use a profile called VM. So let's say AWS STS, and the profile I have to specify is VM. Now you can see in role as well. What is the different here? If you haven't specified, what is actually difference here is this is a role which is there in this particular account. So if just a role, it will be like this only. And you can also see this role is attached to instance. This is the instance ID. This role is attached to this instance, and this is the role. This, if you see like this, that means this is a federated user role, and this is the ID of federation. So if organizations are using multiple federation, this is the ID of that federations, and this is the username which have this particular which have this role access. And then what we can see, what we can do it now. Let's see VM. Same thing you can do it. Let's check what actually access this VM have. So role policy, any inline policy. First I'll check if any managed policy is there. Just change the role name here and specify EC2 role here. So you can see view only access we have. Now let's see if there are any inline policy. But because keep in mind that we have to check both the policy each and every time. PACU will do automatically will do. No need to do anything. But in our case, if you're doing CLI, you have to do it. So until you are not familiar with the CLI, don't go with the directly tool. Otherwise, you will miss the actual concept happening in the back. So let's copy this one. And here you can see I have simply view only access. That means it's lesser than a reader access that I have with managed identity. But I have one more permissions. That permissions, this is a inline policy attached to this role. But let's see what exactly permissions have. IAM, AWS IAM, The command, you can use it. You can take it from here as well directly. Get role policy. We identify that this have a, if you want to see actually what actually inline policy, what permissions this contain, then and you can use this policy name. Policy name is, role name is this one, policy name is this one. Okay, very simple. Okay, so let me draw a diagram here. So you will get a what till now what we did it, what we executed it, what we achieved it here. One second, I'll go here. Or you can also see it here from this portal. Yeah, I think it's better. You can see what we did it. First, we did the enumerations. We identify the, okay, you can see, yeah, definitely we'll complete this module. Don't worry about this one. So you can see we did recon here. We identify that there is one, we identify that SSO URL of that belongs to this particular organizations. We also identify some of the leaked credentials there. We authenticate with the that particular user account, and we identify some of the VM. So a lot of VMs. So there are two VMs are there. We identify their VM, IP address there. Now what we did it, we exploit the VM and we retrieve the temporary token from there. So we retrieve the, so you can see we retrieve the temporary token from that VM. And the VM, the role this is assigned to that VM is here. You can see. Now from the reader access to what we have a lambda star means lambda admin permissions that attached to there. And there is three more different permissions here. Keep in mind that now what we are going to do it here. What will be our next step? Very simple. Uh, so suppose you have a user name is emp01, which have a read-only access. That's the first read-only access, right? Now what we did it, there is one VM, we exploit that VM, and this VM have a lambda admin permissions. You can see the permission that this VM have a lambda admin, along with there is one more permissions called IAM pass rule. That is really important here. What this permission can do? So IAM pass rule is the IAM permissions that allow the users to create, that will basically allow the user to assign any existing role to any resource that you are going to create it. Again, suppose the pass role permissions allow you to attach an existing role which is there in your AWS account. You can attach this existing role to any resources, but one condition is the attachment can be happen during the creation of that resource. So suppose if resource is already there, if any other VM is already there, you cannot attach. So this pass role permission is only applicable if you can attach any role. Keep in mind that you can attach any role, because in this case I have a resource restriction is a star. That means I can attach any resource I can attach any role to a resource, but one conditions resource should be during the creation of that resource. So I have already have lambda function, lambda star permissions. So I can create a lambda functions and I can attach any existing high privilege role to that lambda functions. Okay, so there are two different scenario. IAM pass role simply allow you to attach a role to a resource, attach any existing role to a resource. But one condition can only be attached while creating a resource. Suppose if you already have a resource, you cannot attach it. If you are creating a resource, you can attach any role to this. And that's the one we can take advantage to escalate our privilege. So you can see how we escalated our privilege. First one, we have a read-only access. Then we'll get a lambda admin along with IAM pass role. Now what we are going to do it IAM pass role or password IAM pass role. Now what we are going to do it here, we'll see if there any high privilege role is there, because pass role allow us to attach any high privilege role to a resource, but one condition, it's while creating a resource. So what we can do, so suppose you can see there is one role, high privilege role. There is one role, this is high priv role. What we can do, we can create a new lambda functions, because we have a lambda admin, so we can create a lambda functions and we can attach this role. This is happened because of we have a IAM pass role permissions. Okay, so we can attach this role and then we'll get a high privilege permissions there. So first we have to identify if we have any high privilege role in that AWS account. Okay, so let's see, we can do it. So what we are going to do it next is, our motive is to create a privilege escalation or persistence. So let's think about the scenario. We have a read-only access and we have a lambda admin and pass role. Just by looking these misconfiguration, we know that we can create a lambda function and we can attach any existing high privilege role. So because of that, we can escalate our privilege. So what we are going to do it here, we just want to check if there are any high privilege role are there or not. So you can use this command AWS IAM list role point. Yeah. So let's open a new one tab. So there are multiple roles, hundreds of roles are there. But keep in mind that one more thing. So if you look at the role, this is how a role look like. You have a role name, role ID, ARN, very simple. Now if you're looking for assume policy, you can see where we can attach this role. And that's how it's called assume role permissions. Just by looking for assume role policy, you can see this role can only be attached to lambda functions. You cannot attach this role to any external user or any internal resources as well. This role can only be attached to a lambda function. So this is really important. You can see this role, this is a cross account role. So you cross account, user which is there in another account, this role can only be assumed by this particular user which is there in this particular account. So this is how you can look it for roles there. Now what we are interested is, we have a lambda admin and we are going to attach a role to lambda functions. So we are looking for a lambda role. So you can also see this is a lambda role. So we can attach this role. Then we will see if there are any other roles are there. And once you have a role, you can also see their permissions as well. So let me check all these things. You can see all the roles are there, and just by just looking the name also, you can see this is also cross account role because this is user. Just see the assume role permission and you can see. this role can only be attached to EC2 instance. We cannot attach this role to Lambda function. Okay, now we are looking for role. So you can attach any role which is have the Lambda as a assume role. This one. But I'm just looking for this particular lab. I'm just looking for this one role. Otherwise, you can attach any role. But before attaching this role, you first check the what actually permissions privilege this role have. Okay, so now what I'm interested is interested in this particular role. So you can see this is a role. You can attach any other role as well, which have a lambda. This one, and you can see by looking for this one. This is a lambda role for SSM. Only this role can only be attached to a lambda function. Okay. Now this is the role ARN. What we are going to do it next? We are creating a lambda functions which contain a vulnerable code, so we can retrieve the temporary token and we can attach this role there. So if we have access on this role, that means we have access on highest privilege. Let's see what privilege this role contains. How we can check the privilege? Simply just by list attach policy. Role name, this is the role name, SSM role for admin. I think token is already expired. Let's use the profile. Otherwise, we have to retrieve the token again. I think token is already expired. What we can do, we can go and we can log in again with this employee one where we have a reader access. At least you required a reader access. So I'll go here and I'll copy it here. And yeah, just copy this again, this particular things, and just change it to your, yeah, just change it here. That's it. So let's change it here and let's try it again. Let's see. Yeah, you can see. So there is no attached policies there. Let's see if there is an inline policy for this particular role. List role policy, role name, and role name is this one. You can see there is one inline policy. If you want to see the permission of this inline policy, okay, let me. I think it's better if I paste it in our Discord as well, so you can also try. If you have a cheat sheet, you have a PDF already there, command reference, so you can also take help of that one. Now, if you actually want to see the permissions here, you can take it. You can use this command. Role name is this is a role name. This is a role name. Policy name, just copy from here. Sorry. And you can see the permissions. So this is the permissions contained in this role. And this is a role we are going to attach. You can attach any other role, but this is for a lab requirement. We use this particular role. It seems like we have a SSM permissions. So we'll discuss what is actually SSM, but what we are going to do it, we are creating a vulnerable lambda function. Vulnerable means so you can retrieve that temporary token from there. So I have, let me just download the vulnerable lambda function code for you. So we created a vulnerable functions. Just 1 minute. I have this is there. I'm just sharing one. So it's basically by design buggy code. I'm just sharing the source code with you. One second. Where is code? I'm just looking for the code we have. Okay, so let me download this. Okay, let me go to desktop and let me show you how this code look like. One second. Desktop, extract it. I'll just extract this file. So this is a code look like. So this is basically buggy code. What has happened when you execute this particular Lambda function? It will in Lambda functions, your temporary token will be there in your environment variable. That means your STS or metadata will be there in your environment variable. So what we are going to do, we are just dumping this environment variable in Lambda function, and that means that environment variable contain the metadata of the role which is attached to this one. Now what we are going to attach? We are going to attach to a high privilege role, the role that we identify here. Okay, so now what we are going to do, we are just going to create a Lambda functions. So this is the command, you can use it here. You are going to create a Lambda function because we are a Lambda admin here. One second. We are going to create a Lambda functions. We have a Lambda here. Let's use the privsec function zip file. Let's go to desktop directory, I think, and we have this particular code is already there. Now here you can replace the name of the role that you are going to attach it here. So the role that we are going to attach it here is the role name is SSM for Lambda. So ARN of this role will be like this. So role we all, and this is the ARN of this particular role. Let's save it. And what profile we use it? VM, because only VM have this particular because you can, when you see, only VM have this particular permissions here. Okay, I think okay, let's I think it's already there, no worries. I think if it's already, we can do it, or we can use it for functions 33. It will create a function in the background. You can use this command, but keep in mind that the credentials that we require to execute this particular command is the temporary token that we retrieved from the VM, because only VM have a Lambda function admin and pass role. If you use it for read only, this one it won't execute. So only VM credentials have this one. So we created a Lambda functions. The Lambda function name is called privsec. (33) and the role that we attached here is called SSM role. Okay, so this is how, let's see if it's created. It will take some time to create it. Now what we are going to do, we are going to invoke. Just by looking for the source code, you can see when you invoke this Lambda function, it will dump the, or it will execute the environment variable as a operating system command. So in environment variable, Lambda function is store the metadata token there. So just like in our VM, we can retrieve the temporary token from this particular endpoint, like the same endpoint, right? This endpoint, yeah, this particular endpoint. But in a Lambda functions, it is there this and the all the credentials, temporary credentials stored there in metadata. Sorry, environment variable. Metadata is stored there in environment variable. So you just need to dump this environment variable. Let's invoke this functions. Let's invoke the functions. We can only invoke if you have a Lambda admin. Only VM credentials have a profile have a Lambda admin. It will there in functions code is sorry, function name is privsec33. So you can see you will get a status 200. This is a command, you can use it to invoke it. Okay, now what we are going to do it, we just check it will dump the credentials here in this particular text file. So just check if you have this one. You can see this is the output of Lambda function environment variable. You have your access token, you have a secrets and all these things. Now let's go again and configure in your same CLI. So let's say I just specify Lambda. You just your access key here, the secret here, and your access token from here. Very simple. Now let's go here. Sorry, where it is. It is there. So when we're talking about access key ID, uh, 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 session token is there. So let's just first copy the session token. Start from here to till here. Session token here. Access key ID. Where exactly the access key ID is there? We'll see. This is access secret. So you can use it this as a secret. So in this scenario, we are escalating our privilege. So you can see initially you have only read-only access. Now you will escalate your privilege here. So let me set it there, secret here, and where is access key ID? Region access Lambda function. It will be here somewhere here. Let's see if you have a daemon access key ID here. It is here. So let's see access key ID here. That's it. These are the three things you required. So we dump the credential from VM. We have that role. We created a Lambda functions and we retrieve it. Now let's again what we are going to do. Let's see if what roles you have get. Same thing you can do it with Paco as well. You can just change this VM and then again you do the same operation. See what permissions you have. There is a lot of other modules as well apart from enumerations. By default, privilege escalation module is already there. But if you use that one, you don't know what actually happening in the background. And then profile we are using it called sorry, Lambda. And you can see this time I have a role, I have a access on this particular role. We already know what permission this role have. This role have a permission on SSM. Any questions still here? Any confusion? Okay, so just for a recap, we have an admin use. Initially, we have a user which have a read-only access. Okay, you don't have okay. No worries. I'm just sharing this particular Lambda function code. This is, you require this particular code, which should be there in Lambda function. So you can dump the environment. So we build this one for our testing purpose, but I'm just sharing here so you can reuse that one. So if you're getting that my function zip is not there, I uploaded there, so you can use it. So just for again summarize, we have a read-only access. Then we identify the we have a VMs. We exploit the application running on VM and retrieve the token. And we have a Lambda admin and password admin. Next, we know that we can misuse this particular permission to escalate our privilege. If you have this kind of permissions, you can use it to escalate our privilege. We did it. So we created a Lambda functions, vulnerable Lambda function, and there is a role which have SSM role attached to this one, and we can retrieve the temporary token. Now, what we are going to do it? So if you have a SSM, so SSM basically if you check for documentation of AWS, which is really important. It's basically a system manager which is provide a multiple functionality there. So it's basically agent which is running there in each and every by default in uh, instance, or we can say VM provided by AWS, or AMIs provided by AWS. So what it does, it will help you. Suppose in some scenario, you suppose in some cases, you know that what is basically help you in what area it will help you. Suppose you have a VM or which is running on 22 port, like SSH port is open to audience or public audience. Generally what happen, everybody's try to authenticate and scan it. So by default what you can do it from security point of view, you can restrict to the in a specific IP address and you can access it. Think about a scenario if it's a VM which is doesn't have any public IP address. If it's a VM which is not exposed 22 port to the public audience, in that case, SSM system manager will help you to access that VM. So suppose if you have a SSM, start session permissions, that means in our case we have SSM star. So if you have a start, session permissions, you can access any VM. Doesn't matter if it's a Windows, if it's a Linux, or if it's Windows, if it's Linux, have a public IP address attached to it or not. So that means this will allow you to laterally moment or to compromise any VM in your AWS account if you have a start session permissions there. So it basically, what it does, it basically create a tunnel from your CLI, from your system to AWS to that particular VM. So no need to expose 3389 or RDP port or 22 port to the audience, or no need to have a public IP address, this one. So even if you have a VM which is there in internal network or your VPC, internal network means VPC, you can access this one with your SSM. So now what we are going to do, we are going to laterally move. So we identify that what permissions we have. Now what we are going to do, we are going to laterally move. Lateral movement can be happen with multiple ways, like from control plane to data plane. Means if you have access on CLI, how you get access on one of the VMs, that's called a data plane. This is also possible. One VPC to another VPC, one AWS account to another AWS account, one cloud service to another cloud service, like Lambda to this one to Lambda, VM to this one, and command line to the AWS portal. So if you have a CLI access, how you can laterally move the UI or portal access. In first case, in our case, what we are going to do it, we have a CLI access, or we have just a control plane access. Control plane means we have a CLI access. How we will get a access of a VM which is there in that organizations. So when you use this command, what, because we already have a SSM star permissions. If you have a start session start permissions, you can start you can access any VMs there. So just by looking for the again, what we are going to check, we are going to all the instance which is there. So you can see this is one more instance, but there is no IP address exposed there, right? When we did nmap, sorry, when we did, okay, let me do it again. AWS EC2 describe instance. Yeah, it's going. So the session is going to be finished in the next 10 minutes. So don't worry about this one. So you okay? So you can see there is one more VM. This VM. Can we access this VM because we don't have any key? We don't have anything. Can we access this VM? Yes, we can. If you have SSM start session, because in our case we have a SSM start. That means we have every permission in SSM. But if you just have SSM start session permissions, you can access any VM in your network. But there is one more condition that VM also should have a SSM permission installed there. Otherwise, you cannot access it that VM. Okay, so now what we are going to do it. We are going to laterally move to data plane to our control plane. Very simple. Just use this particular command, SSM start session command, and it will work. I'll just explain what it does. Profile, we have a lambda because only lambda profile have a SSM star. Instance, you just need to specify the instance ID. That's it. It will take everything for you. So this is instance ID. I'm going to use it here, place it here, use it, and run it. I don't have a key, and you can see I'm already there in VM. Just see, I directly access the VM SSM user. I don't have any key. Not, you don't have. You just need a SSM start session permissions. You can access any VM in your particular account if you have SSM start session permission. Okay, any questions here? So this is how we can get the we can laterally move from our CLI to our data or our control plane to our data plane. Now what we can do it here, if you have a VM access, you can see who am I. You already know that you this one. You can try to get the temporary token again, because in this case, this VM have the VM that let's see which instance profile this VM have. Internal role profile. This VM have a different profile or different role attached to this one. So let's again use curl command 169 254 169 254. Let's see if you're same, because you are already there. Latest metadata, IAM, and then security credentials. And this is the role, EC2 internal role. And yeah, you are able to retrieve. Now same thing we did it. Let's copy again in my this system, attacker system. So you understand that from the read-only access, how you can this one. So what we can do, let's say I'll create for VM second, and then you can specify here and this token. And then let's copy from here. We have a access key ID. This is the access key ID. Sorry, this is not the one. Yeah, this is access key ID. This is the secret. And this is a role. Or this is a token actually. And let's save it with VM2 and then see. Let's go here in another tab and let's see AWS. So it will take time. If you understand this one, use the Paco one and just do all these things in an automated way. But keep in mind that if you're doing red team assessment, if you want to be stealthy, you should have you understand how this AWS CLI work. So profile VM2. We have internal roles. Let's see what is actually contain it here. We get to know the permissions. Let's attach policy. I'll just copy from here. Role name. In this case, what is the role name is EC2 internal role. Just see if there are any. This is the permissions that is required if you are configuring, if you are configuring, to configure, SSM. This is the permission that is required. Keep in mind that if you see any instance which have this particular configuration, that means you can directly access through SSM with that VM. If you don't have this permission, you cannot access it. So this is the one permissions you required. Let's see the inline policy if you have, because this is the normal one list. Let's see if there any inline policy for this one. Uh, there is one assume policies there. If you want to see actually permissions of that policy, you can use this command. Again, same, we are just going to do this, but in this case, policy name is assume policy. So now you can see in this case, what we are going to do it here. You can see you have a STS star permissions. If you want to assume any role, you require STS assume role permissions. That means you can assume any role on this particular account. So see, if you see this one, let's do this one. Let's identify. Now let's draw this one so we'll get an idea. Okay. Now you have a, so what you can say, you have a, this is a SSM role. What you did in SSM, you have the access on another VM where you have a STS permission. That means you can assume any role, but role is also required in. So assume role is a two-way conditional. Role is also allow you to assume that role. But in this case, you have a assume role star permissions. Let's see what we can do it next. Now, what we are going to do it, we know that we can assume this role. So identify the role which can be assumed by this particular account. So we get the access on this one. So what we did it, let's see any role. So we completed till here, right? we SSH to that particular VM from till here. Now we identify that we have permissions to assume a role. So yeah, that completed. Now you have to identify a role. Again, you have to identify a role. All the roles you have to identify it here. So you can see this is the ARN of the. So let me check here. You can see what is actually role that you have. Role you have EC2 internal role. Now you have to check for each and every role and you see if anybody allow me to assume this role. EC2 internal role. Understand how this assume role work. That if you don't have this idea, it won't work in this case. So just for 2 minutes, I'm just explaining how this assume role work. So suppose you can see you have a one role. This is a role, right? This is a role, and there can be a user, and there can be another role, or there can be a user. Now, if this user, so suppose this role have a admin policy, administrator policy, administrator policy. Now, suppose if a user or role want to assume this role, means access the permission which is have on this particular role, how it's possible? What you can do in this scenario, you can allow this user, and suppose this account ID is 1234 and this account ID is 567. Now you can 1234 slash role or 1234 slash user can assume me. So these two user which is there in this particular account or can be in the same account can assume this role. Here you have to use STS assume role permissions, which is going to be assumed. You require these permissions. Other end, the role that you are going to assume allow you to assume this one. That means in their uh, assume role policies that will allow you to assume this role. In this case, in our case, this is how this user or this can assume this particular role and can have access the same permissions that this user have. Okay, so I think first we identify what is actually role which is allowed to this particular role to be assumed here. So the role name is EC2 internal role. Let's see all the role. You just need to check their assume role policy document which allow this role EC2 internal role. So it's lambda functions. This is for this one. This is for another one. No, you can see this one. You just check this policy. This is not for, this is for another thing. This is for any other purpose. You have to check all the roles. There are shortcut is also there, but I just want to explore each and every role. You can see this is policy document. This is for SSO. This is for cross account user, but we are looking for this role, EC2 internal role. You can see now. You can see this particular role. The role name is EC2 internal role. This is the same role that we are going to assume, but this is not the case because we are going to want to assume this role. You can see in this case, this is a role called internal easy to assume role. There is another role which allow our role to be assumed, because you can see in their assume role policy document, this is allowed. This particular role that we already have access is allowed. Okay, so in this case, what we can do, we can assume this particular role, internal easy to assume role. Name is just a confusion, but we can assume this particular role because it's allowed to us. In our side, we already have STS permissions. We already have STS permission. You require STS assume role permission, and you can assume this role. So use this command, open a new one. Use this command, assume a role. 1 second. I think the command is there. 1 second, 1 second. I'll just take the command from here. Okay, so now what we can do it here. So first, you can use this command called AWS assume STS assume role, ARN of the role, and this you just specify the session ID. So you can use any session. Now what happened? What we are going to happen is we are going to assume the role which is there. This role. We are going to assume this particular role here. Let's assume this role, and from which sessions we are going to assume this role is profile VM2. VM2, that means from this VM, because this VM have a STS star permission here. Now let's do it. Let's see, and you can see I'm successfully assumed this role for this. So this user, the current user, we have their temporary credentials, can assume that remote role. This role can be same account, or this role can be a cross account. So this role can be a master account. So this is how you can escalate your privilege. Again, this is the way we can assume this role. You can set it. You can set up the same thing again, and it. Let's see what permissions you have. So just copy the entire thing and just created here is assume role. Access key ID, you can take it from here. No worries, if you miss some point, you can go and you can check the recordings again. Here, and then you can copy it from here. Let me copy this one. So this is how the assume role will work, right? And same what we did it. Let's see if you have AWS STS and the profile in assume role. And you can see internal easy to assume role, the same role which is there internal, we are able to assume it. So this is how you can, this is not only for same account, you can have for a cross account as well, and you can escalate your privilege as a administrator on your master account just by assuming role. So please make sure you have to check permissions on both the side. First side, if you are going to assume it, you have a STS assume role permission or not. If you have, you check other end in their assume policy document if they allow you to assume the role or not. Okay, so, and there is one more trick here. If they put it like in this policy, if they put it like root here, just like in this case, suppose in this case, if they put it like root here, that means any user, or if they put it star here, if you put it root here, that means any user can assume this role. If they directly put it star here, that means any role or any user can assume this role. That is really important to keep in mind, that so we have to only target those one which will allow either us or everybody to assume this role. And from your end, if you are going to assume, you should require STS permission, STS assume role permissions. Okay, now this is a same thing what we're going to do it here. We'll just check if there are any policy attached to this one. You can see this role have administrator access. Now this is how you can become. So you assume this role. So what is happen? You there is one more role. You assume the role, assume role, which is internal role. So there is one role you assumed or trial role, and that role have administrator permissions on AWS account. So you can see just by having a read-only permissions, you escalate it, you did lateral movement, you did privilege escalations, or you can also create a backdoor there, and then you achieve to become an administrator on AWS account. So you can see you have administrator access on AWS account. You can see the permissions here. Now, if you are administrator and if your objective is to not just be administrator, you can check the database or any other. You can do any actions there. So let's see if you are able to get the bucket, anything which is there in a bucket. So you can use AWS STS ls command, and you can do much more thing if you become an administrator there. So you can, there is one private bucket. Use this, the bucket objects within the bucket, and you can dump that. So you can copy it, and this is your, so you can use S3 like this, and it will be like this: private data slash private text. And now you have administrator access, so you can do or because you can also specify the profile as well, but if you have an administrator, you can do anything there. You can also specify profile if you want to. Profile means the profile we have called assume role. Okay, now you can check the private. So this is how you can, you can see that there are other information. So this is how you can exfiltrate the informations which is there. So this is the last objective. Now you can just see the flow, how it's work. You have initially you have a read-only permissions. Here you have a read-only. You enumerated the AWS apps. OSINT you did it. OSINT, what you have, you enumerated the AWS SSO URL plus user credentials. Now you get you have this employee credentials. You have read-only access. What we did it, you did some scanning, internal nmap scanning, and you identify there is a 80 application running on 80 port. You exploit it, and there are two permissions policies attached to this one. One is lambda admin permissions, and another one is IAM pass role. So if you check for the IAM pass role, you identify that this is allow us to attach any role while creating a resource. So you have a lambda admin, so you can create a resource. So I created a lambda functions with vulnerable code there, and I can attach high privilege role, the role which have SSM there. You can even attach any other role as well. Now, if you have SSM role, you know that if you have SSM role, you can access any of the VMs, if it's internal, external, Windows, Linux, without having any credentials. So you know that there is another VM which you have. You compromise that VM, that the policy and the role which is attached to that VM allow us to assume a role. Now, which role we can assume that will allow us back to assume that role. So there is one role when we look for their policy document. That policy document allow to this role which is attached to this VM. So VM, this role can assume this role. It's tricky, but this is how we can even user and role can assume another user. Another role. Yeah. So once you assume this role, we dump the temporary credentials. Once you dump the credentials, you will become a so you can see you will become a administrator access on AWS. Now you have a S3 bucket. You can exfiltrate the data exfiltration. So this is how your objective will be achieved. Keep in mind that if this assume role is not only for limited to account, if it's their master account or cross account, you can also do that thing, and you can even laterally move or expand your access there. So this is how the whole operations we done it, just by having a read only permissions or just by doing the authenticating there. Okay, any questions anybody have? I think this is the operations. If anybody have any query, any questions, I request you to go through the recorded video once, so you will get a better idea. You can do the same thing with Paco as well, but I'm not suggest it, because if you don't have a understanding of the conceptual things, you don't know how actually tool is working it. Yeah, I know it's little bit, a lot of things is covered here, but if you go through it, you will get a better idea this day. So request you to please don't use Paco as of now. Try to understand the conceptual things. Once you are comfortable and you understand that thing is there, then you can use Paco or any other automated tool to do the same stuff that we are going to do it here manually. Okay, I think we are already running out of the time, but we just need to complete the sessions. Anybody have any query, any questions? If not, I think we can conclude this session. So tomorrow we'll discuss about Google Cloud one. That's how we can do the multiple things in Google Cloud. And day after tomorrow means on third day we'll discuss about Azure and Active Directory environment. Sorry, some of the on-premises things as well. But the concept will be the same. We'll first discuss about fundamental and then we'll go for a red team operations there. Okay, I think any questions? If not, I think we are going to conclude the sessions. Once our training is completed, we'll upload, we will upload our recordings to our LMS there. Okay, thank you so much, everyone. I'll wait 5 more minutes. If you have any questions, any query, please let me know. I'll be available here for another 5 minutes. No worries. Any questions, any query you have, you can ask it in Discord or go to, or you can directly ping me or DM me. Thank you so much, guys. Oh, Lambda functions. What exactly error you are getting? I think you haven't specified. First, just change the Lambda functions name. Let me see where we created Lambda functions. So this is the command reference you can take use of if you're getting Lambda functions. I think the problem here is maybe you haven't specified the file in a it's very simple only, but please make sure, even sometime what happen, we forget to specify the profile. So you should require the profile that you selecting, you should require lambda, the same permissions, lambda admin as well as IAM password, otherwise you will get an error. This is generally happen because there are a lot of profiles we already set up in our CLI. So please make sure you understand the correct profile that we use it. No import module found in Lambda functions. No worries. Let me check if I share the correct code with you, because if I know this is generally happen, just check my functions. Yeah, that's correct. And just check the code if you have the correct code like this. Maybe would you unzip and zip again? That's vary from, because this is happen if you zip this particular folder again, it will come into the another folder there. The folder will be inherited there. So please make sure you directly use the zip that I shared with you. No need to unzip it. Just directly use the zip. Okay, good night everyone. So I will see you tomorrow. Meanwhile, anybody have any questions, queries, just let me know. Otherwise, we are just closing this one. Thank you. Thank you so much, everyone.